Good evening, everyone. Am I audible?
Yes, ma'am. Good
Yes,
evening.
ma'am.
Okay. Let's wait for 5 minutes. Let everyone join, then we'll start. Okay. Okay, so I can see a lot of people have joined, so I'll just begin. So this is your first revision session for quiz 1. There will be one more session, I think, tomorrow, right? It's scheduled in your calendar. So today I thought that we would discuss all the topics, but it's better if we solve questions rather than do the theory, right? So I have compiled around 20-30 questions that we can solve. Those cover all of the topics from weeks 1 to 4. But before we start with that, so since I did not take the session for week 4, I think. So did you do the relational algebra, that part, right? Did you do division operator? Can anyone tell me?
Yes, ma'am.
Okay. So division operator, you have solved problems on that, right? Now,
Yeah.
if you go through the slides, you can see that there is a relational algebra expression which stands for the division operator. So every time when I teach that part, so I explain that entire expression with an example, so it becomes more clear to you, because that expression can look like, it's like looks a lot unrelated. So if you want, then I can explain that part to you. So you can just raise your hands. Okay, all right. So see, it won't take much time. We'll just take a small example and just show you how that expression actually relates to the division operator. Okay, so I'll share my screen.
Ma'am, there is one quick doubt. I mean, not related to DBMS, but can I ask? Looks like
Um,
there was
yeah,
this topper announcement
yes, yes. It's
sessions.
going on right now only.
Yes, ma'am. Someone got like 10 CGPA. So does that mean she got like all questions, everything right? Not even a single was incorrect.
No, I don't think that necessarily means that. I mean, 10 CGPA does not mean that every question is correct. Okay, it might be some type of relative grading also. Maybe that's the person who got the highest marks among
Okay,
everyone, but
ma'am.
that
Okay.
might not be the full marks. Okay, is my screen visible?
Yes.
All right. So anyone remembers that expression that corresponds to your division operator? It's a little bit of a longer expression. If you remember, you can tell me, otherwise I'll just write it. So no need to memorize this, okay? Just understand. So if I say, let's take two tables, for example, one is your student table, okay, and one is your course table. Now let's say student table has two attributes, student ID and course ID. This course ID is nothing but a foreign key that is coming from course table itself. Let's say course table only has one attribute, course ID. Now in student table, let's say we have some rows like S1, C1, S2, C2, S3, C1, S1, C2, and let's say S2, C1. These are the rows in student table. And in course table, let's say we have only two rows, that is C1 and C2. Okay, now if I tell you that student divided by course, so what will I get in my result? Anyone?
S1.
Sorry?
S1 and S2.
S1, S2, yes, ma'am, both.
S1 and S2, correct. So this is how division operator works, right? So what did we check? That these two values. So which of the SID values have correspondingly C1 and C2 both combinations present, right? So S1 is combined with C1 once and C2 once. So S1 will be in our result, similarly S2. But S3 has only one combination with C1. It doesn't have a combination with C2, so it's not in the result. Okay, so this is pretty simple. Now you can
Excuse me,
look in
ma'am.
this. Yeah.
So, ma'am, would there be only two rows or there would be four rows?
No, see, how many distinct values are there in this course table? Two values, C1 and C2, right? So what is the other attribute in student table that is not in common? SID. So the result will come from SID only. Now what we have to check is which of the SID values are corresponding with every CID value. Right. So S1 is corresponding with both CID values. S2 is corresponding with both CID values. But for S3 we only have one combination with C1, no combination with C2. Right. So division operator takes only those values which have all the combinations. So S1 and S2 will be in our result. So this is how you will solve the questions in your exam. Okay, so this type of question might be there. But now if you look in the slide, so there is this one expression. It's like this. So projection x minus y.
Ma'am, may I?
Yeah.
What if there's one more S1 C1, an identical tuple? Is it possible? Then you get multiple combinations of
But
S1
that is
C1.
not valid, right? Because
It's not valid,
if
right? Yeah.
if I say that student ID is the primary key, then you cannot have, even here also if I say student ID is primary key, then it is not valid. But we
Yeah.
don't have exactly similar two tuples, right, in a relation. So there will be
Got it.
only one such combination. Even if there is one more present, it is not a problem. Still S1 will be in your result. Okay, but it's not a valid table. So yeah, this is the relational algebra expression. So projection x minus y coming from table R, and then we have this big expression projection x minus y, then again projection x minus y from R cross S table minus projection x minus y comma y from R table, and then close. So this entire expression is the equivalent to the division operator. So how does this and this, how do these two relate, right? How can I get these same S1, S2 values if instead of division operator, if I write this expression? So this is what I want to discuss, right? Because you need to understand, even if it is not necessary to memorize this expression, you still need to understand how it is the equivalent. So let's consider that our student table is our R table, okay, and our course table is our S table. Now we will just break down this expression into parts. Okay, so let's take the first part. So first let me write what is X. So X is set of attributes of R and Y is set of attributes of S. So what is X? SID and CID, and Y is just this CID. Okay, now let's take this first part of the expression. So what does this mean? X minus Y in projection, and I am projecting from table R. So first tell me what is X minus Y. What does that give me?
SID, ma'am.
Only SID, right? So this part will evaluate to SID, and SID values coming from where?
R.
R table, right? So when I take a set operation like this, right? When I take some projection or selection operation, so what is the one constraint? Do I take duplicate values? So if I take
No.
SID here,
No,
what
no.
will I have? What will SID contain?
S1, S2, S3.
Correct. So S1, S2, S3, one occurrence of each. Next, now let's come to this bigger part of the expression. Okay, so we will do this part by part. Let's first break down this part only, this first part of the difference. So again it is pi x minus y of R cross x. This means what? This is a cross product, right? Simple cross product. Between whom? This SID and the S table itself. What is our S table? Course table. So I have this SID, right? This expression and this expression is same, and then I have to cross it with S. So what will I get? There are three distinct values that come from this part, S1, S2, S3. And if I cross it with S table, how many rows S table has? 2 rows. So how many combinations should I have?
6.
6, ma'am.
6.
Right. So let's write down those combinations. So this is what this entire expression will give me, this part of the expression, right? So SID, CID. So for S1, I will have S1, C1, S1, C2, again S2, C1, S2, C2, and S3, C1, S3, C2. Fine. Up to this, everyone is okay, right? Now this part. So this evaluates to this evaluates to this. Now this part, what does this evaluate to? So again, now you have from R table only, I am projecting x minus y comma y. What does this mean? What is this? So x minus y means what? Whatever is left in R table, when I take the attributes of S table out, that means what attribute is left? SID. Comma y also, we want y attribute also. So y attribute means what? CID. So x minus y comma y, both of these columns I am projecting from R table. So isn't this the original R table only? Right? Is there a difference? So if I write the expression for this, so this will contain both SID and CID. SID coming from x minus y, this part, and y itself means CID. So both columns will be there. Both columns are projected, but from R table. So what will be the values? Exactly what values are present in R table itself. So what are the combinations? C S S1 C1, S2 C2, then S3 C1, S1 C2, and S2 C1. Anyone has a doubt until now?
Ma'am, shouldn't it be Cartesian product when we're taking x minus y, comma y?
No, this is in projection when we write the subscript. What does that represent? The columns that we want to project, right? Any type of operation, if you want to do, you have to do it in selection operation, right? Projection only means projecting columns or attributes. So when I write, if I write project A comma, let's say B comma C from R table, that means you are going to project both these columns from this particular table, right?
Can you explain the middle term, ma'am?
Yeah, this one, right?
Yes, the
So
whole term.
this first part is this same as this, right? This is okay.
Yes.
Three
Yes.
distinct SID values. Now these three distinct SID values, you have to do a cross product with whatever is present in S table. S table has only this CID C1 C2, two values. So 3 cross 2 is 6 columns you'll have, basically all combinations. This one.
Okay.
Okay, now next step is that we have to do the difference, right? So these two are actually, a difference is happening here between these two sets. So this set minus this set. So let's take out the common combinations out. So S1 C1 is present here. S1 C1 is present here also. So I can remove it. S2 C2 is also present here. Okay. So S2 C2 also you remove. Then S3 C1, see all combinations are present here. So all of them will get cancelled out. S1 C2 will also get cancelled out. S2 C1 will also get cancelled out. So all 5 combinations from here are cancelled out in the difference. So what is left? S3 C2. This is what we are left with. Right now, what is the outer projection? Pi of x minus y. So this is what is left after the difference. Now from here you have to take pi of x minus y. That means what will be projected from this row?
S3
S3
only.
S3. Only the SID, right? X minus y means only SID.
only.
SID CID minus CID. So only SID. So only take the SID that is present in the resultant row. That is S3. So this entire
Ma'am,
expression, this one, evaluates to just this S3. Okay. Now you do the actual difference, this difference. This one. So this is the set minus I have to do S3.
Only S1, S2 will be left.
Right. So S3 gets cancelled out, only S1, S2. So this is your result, which is same as the division operator. Right.
ma'am, can you explain x minus y again?
See, these are the set of attributes X that are coming from R table, and set of attributes Y is coming from S table. So X minus Y will give you what? What is the common attribute that will get cancelled out? So CID is getting cancelled out in the difference. So X minus Y will give you only SID. Understood?
Yes, ma'am.
So the point of this is just to show you that this expression will evaluate to exactly what the division operator does. Okay. Anyone has any doubt in this?
Ma'am, while we get such expressions, how to divide it and how to go through each one, like
See,
where to
division
start?
operator is just an operator, right? Now,
Uh,
in the logical part, so you put an operator, but how does the computer understand that what that operator does? So this is the logic, actual logic, right? So this is the corresponding relational algebra expression for that division operation. Everything has a corresponding, see, every relational algebra, relational calculus, these all are having equivalent power. Okay, relational algebra, tuple relational calculus, domain relational calculus, for a single query, any SQL query, you can write in the form of relational algebra or relational calculus, TRC, DRC, anything. But if you write the same query in relational algebra, TRC, DRC, both all these three forms, they will have equivalent power because all of them are representing the same thing, right? So this is also the same. So this is just an operator, but the actual logic behind this is this. So division, like we know that multiplication corresponds to what operation? Addition, right?
yes,
So similarly, division, what do we know? Just basic arithmetic. Division means what? Subtracting things. Right,
yes,
when
right.
we do division we just do subtraction. So here also that subtraction is only happening. See, there are two subtractions here. So this is the main set and this is what we derived from this entire thing, entire expression, that you have to subtract out from this set. So this expression, how it is derived, that I'm not going to go into. That's a very much more detail, but there is no need to like memorize any of this. Okay, if you know how to solve the questions like this only, this is enough. Okay, since you already gave the correct answer that SID will have S1 S2, but still, since I didn't take that class, so I just told you this part now. Okay.
Ma'am, actually, I was asking like if we are given such expressions, then is there a rule like we use Bodomus to get like
No, it's not like
some
that. See,
arrangement?
relational algebra expressions, you can uh, evaluate them however you want. Like this one I evaluated part by part. So you just have to make sure that you follow that brackets, right? So that's what you mean here, that if I have
Yes.
something in brackets, so that will be evaluated first, right?
What will follow what, like where to start and then how
So
to
here
proceed.
in this
That's
expression, you see that there are two brackets starting here, and those brackets are also closing at the end. That means this entire expression is one, right? From this
yes.
expression, now you have to do the projection. And after the projection is done, then whatever is left with that you have to subtract from whatever this expression evaluates. So it's just like simple math equations how you solve. Right. The same bracket, that principle holds here also. But it is easier if you have longer relational algebra expressions, you can evaluate them by just breaking down the expressions part by part. But this type of question won't come. Okay. We won't give you relational algebra expressions and ask you, okay, not exactly like this. I have some examples, okay, that I'll discuss. Then I guess it will
Ma'am,
become clear.
can we have other relational expression also which shows division?
No, this is the, you can write a TRC thing for this, equivalent relational calculus. Relational algebra expression that is equivalent to this. Okay, I haven't tried. Might be, could be. Maybe you can write it in some other way using relational algebra. It could be possible.
Uh, Ma'am, we won't be given this expression alone and asked to
No, no,
select
no,
the
no, no,
type of ratio.
no.
Okay.
It's just this expression was present in the slides. I explain it every time, so I just did it now. Okay.
Ma'am, in this session, like what topics will you cover? Can you just brief
Everything.
next
See,
session?
this is the slide actually that I am going to cover now. So here I have all of these questions. Okay, these are all PYQs, but
So
important
is the
ones.
slide be uploaded somewhere, ma'am?
Okay, after the session, I'll ask you sir to upload it. Okay. Or I can post it on Discourse and I'll pin that post.
Okay, ma'am. Thank you.
Okay. Yeah. So, uh, division I hope is clear for everyone, right? So we can move on to the actual PYQs now.
Yes.
Ma'am, I just had a silly doubt. I'm having trouble in accept and exist, not exist.
Accept and exist.
Yes, ma'am, both.
Accept is different. See, accept means, okay, I have questions regarding both. Okay, here only. So when I come to those questions, I'll explain. Okay.
Yeah, ma'am, that works. We
Okay, and
can solve them along.
if it is not possible to complete all the questions today, still at the end you remind me once. If those questions are not taken, I'll explain those expressions for you. Okay, accept and that exist.
Okay, ma'am.
Okay, so I'll give you the solutions for all of these questions. Some of the solutions I've added in this slide only, but first you solve. So this is the first question. This is from week 1. The lowest level of data abstraction is which one?
Physical level, ma'am.
Physical.
Lowest level.
View level.
View level is the lowest level,
Physical.
right?
No, ma'am, physical level. View level is the topmost.
Okay, this question is written in that manner. Okay, do you have the answers to these PYQs also?
I
Because
think, ma'am, yes, I
this
came
one,
across this question in one of the PYQ. It's physical level only.
just one
It's
second.
physical level, ma'am.
Physical is the lowest, na? That schema, that part.
Yes.
Okay, but okay, now if I ask this same question, if I ask you that which is the highest level of abstraction in terms that
View
it has
level.
the most security,
Mu level, right?
which level is okay, first tell me which level does the user see?
View
View
level.
level, ma'am.
View level, ma'am.
View level, ma'am.
View level. Now which level has all the tables, relations,
Logical level.
logical level? And what
Logical
does physical level comprise?
The
Ma'am,
actual
it
storage of
storage
data.
basically
and
comprises
structure.
of how the data is stored on the disk or the hard drive, the sectors and the bits and bytes of the data.
The flat file.
Just a second. Let me reshare that. Yeah. Okay. So lowest level of abstraction is my physical level. After that, which level comes?
Logic.
Logical.
Logical.
Then
View.
View level.
view level. Right. So what if I am a database engineer? Which level will I interact with?
Logical level.
Logical.
Logical. Logical level. Or I can also interact with the
Physical.
view level also,
Physical
right?
level, view level as well. Yeah.
View level.
Physical level, though that level is like the highest form of abstraction in the sense that it actually hides the most amount of information. Okay. So that the access to the physical level or the schema and everything, that is basically given to the database administrator, right? Now they can grant access to the engineers or to the
Okay,
users.
okay, ma'am. So abstraction, and we were thinking of
Yeah, that's what
data
I said.
independence.
Yeah. But
Okay.
this question, and if they ask you what is the lowest level of data abstraction, then you're right. Physical level is lowest level. Okay, and highest level is view level. But in my mind, I was thinking that which level hides the most amount of data or what is the most secure level. So that is actually physical level, because any changes made to physical level, those will be reflected in the logical and view level also, right? But any view or logical level changes might not be, reflected in the physical level.
Ma'am,
Ma'am,
but
but what?
we
No,
learned
we
about
saw the
physical level
independence, data
independence.
independence, ma'am. So
Yeah, physical
data
data and
independence at physical level means the upper levels are not affected. That's what we
yes,
read.
yes, exactly. So if I change the schema, right? So that might not change the view. That's what you are saying.
Ma'am, but view level hides the most information such that it is only shown what we allow it to show right now.
Yeah, right. So you can write, you can
Then isn't
create
it
a
the most
view.
secure?
You can see, you can create a view and it can show you particular information from the table. But what is the level of database which requires the most security, because it is the skeleton of the database, that is the physical level. Okay, but in this particular question where they are asking about levels of data abstraction, physical level is the lowest, then comes logical, then comes view. Yeah, this is correct. But which level affects the most? If you make changes to it, if I make changes to a view level, will it affect my physical level?
No, ma'am.
No.
Right. But if I change the schema of a database, that changes everything.
Yeah.
Right. So this is what I was thinking. But for this particular question, physical level is the answer. Okay. So from week one, you are just going to get such 1-2 marks MCQs from these theoretical concepts. Okay. This is also one good question. See,
Ma'am,
suppose a
excuse me.
company. Yeah.
Sorry to interrupt, ma'am. I just had a doubt in, practice assignment question, ma'am, and GA question related
I
to this
think. I think.
data abstraction.
Okay.
Week one.
Just do one thing. You note that. Okay. I'll take all the doubts at the end of the session, because tomorrow I think only it's a PAGA session only.
Sure.
Tomorrow's session. Okay. But still note that. I'll take it.
Sure.
See, this
Ma'am,
question says
physical level will keep
the database
the
schema.
database schema or the hardwares or something like that.
It is the skeleton of the database. Okay. That is where you make the decisions that what the table will look like. Right. What are my
But
primary keys?
that's the logical level, no, ma'am?
Logical level means relationship among different tables. That is what is the foreign key, which table is it referencing. Physical level contains all the actual information of how the data is being stored. Okay,
Ma'am,
so
storing
when
is physical level and relating is logical level, viewing is view level,
viewing
ma'am.
is up to the user, yeah. So user can view any part of the database that he has access to, obviously. So physical level content, see next when we learn about indexes and all that. So there you will learn how database indices are stored. So they are stored using some data structures, right? Like all of these databases and everything that it contains, all of this is stored in the memory using certain data containers, right? Those are called data structures. So we'll use trees and other things that we will learn in advanced week. So how all of this information about how data is being stored, what is the schema of every data of every relation in a database, these things are stored in physical level. Now the relationship between these, what are the relationship between different attributes, foreign keys, all of these will be stored in logical level. And view level is just to give you very particular information about the database that you can have access to. Okay. Okay. See this one will make it a little more clearer. So let's suppose a company wants to determine whether the price of the commodity will be an attribute in the shopping database or not. Right. So I just want to know that in a particular database if I want to have an attribute or not. So which one of
Logical level decision.
Physical
Logical.
Logical.
level.
Logical
Physical
level
level.
decision.
it's a logical level decision, right? Because here to find out that whether this price of the commodity is like if it's a good decision to put it in the particular table or not, that is a logical decision. It's not a physical decision. It's not about how I'm storing that. It's about whether that has any relevance, right? Whether adding the price attribute will add any relevance to that table. So here you are using logic, so it's a logical level decision. These types of easy questions also you have 2 points for these, right? Now from week 1, since the weightage is very low, we won't discuss too
Left
many
out.
questions.
Left
Let's
out to
discuss
join.
this one.
Left out to join,
Yeah,
madam.
so this is a left outer join, right? So take these two tables. Now it is
R
asking
is
that
left.
R left outer join S. So how many tuples will you get in that? So everyone knows what is left outer join. You take the matching ones, matching tuples, and the ones that are left in the left table, right? The ones that are still left, which don't have a match in the right table. Those also you have to add. So here first check what are the common ones.
B and C.
B and C are common. Okay. So how many tuples can you find which are common?
3.
So if I take R
2.
left outer join S. Okay. So 2, 3. This is one value. So do I find a match for this?
Yes.
Yes,
Yes,
2,
ma'am.
3.
There's
So
two
there is a
matches.
match. This one also, and there is this match also. For 4, 6, is there a match?
No.
Ma'am,
No.
7, 3.
7, 3, I have a match. Correct. So this one for 7, 3. So now till now how many matches we have found? 3.
3.
3 matches.
Then for 3, 4, is there a match? No.
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 So what all is left in the left table? Row 2 and row 4. So they also have to be added.
Total 5 tuples.
So total how many tuples? 5. 3 matching ones and 2 that are already left in the left table, that remain in the left table. So for this the corresponding D value will be what? Null,
Null.
right? So the answer to this is 5. This type of question is very common. It can come 3 points.
Ma'am, we consider R to be left because of the symbol, ma'am,
Yeah,
since it's pointed towards R.
correct. Whatever is on the left side of the sign is the left table and this is the right table.
So D also
Ma'am,
will be
if it
null.
is an inner join,
Inner join means then you have to specify. Na? Inner join, you must specifically write that based on which attribute I want to perform the inner join.
okay.
Right. If it was a natural join, then it will take both B and C and it will have 3 rows. This, and this. Right.
And D will be null, ma'am.
Yeah, D will be null for those rows in the R table which don't have a corresponding match in the S table. Like this second row. So it will be 2, 4, 6, and for the D attribute, it will be null.
And what about
Uh,
other rows? Other rows D will be present, which is common.
Yeah, like in this one, 1, 2, 3. What is the corresponding D? 5.
4. Okay.
Okay.
So, ma'am, in left outer join, it takes common from right side table and uncommon tuples from left side table. Can we say
Yeah,
this?
see, if I have an attribute called X, it can be one attribute, it can be a set of attributes which are common between both tables. So wherever those attributes have matching values, those tuples we will take. Other than that, whatever is remaining in the left tuple that did not in the left table that did not find a match, those tuples also we will take with a null value for the right hand side table attributes.
Okay, ma'am. Yeah.
Ma'am, only natural joins are considered as inner join, ma'am, where only matching attributes are.
Natural and inner join are different, right? Natural join takes every attribute that is in common between them. So here if I did a natural join, it will take all the matching ones only. So for B and C, it will find the matching values. It will find 3 of those, these 3. So these 3 tuples only will be there in the result. In case of inner join, you can specify whether you want to perform inner join based on attribute B, based on attribute C. That's your decision. Okay. So natural join will take every value of common attributes together.
And inner join will specify the particular attribute, ma'am.
Sorry, come again.
In case of natural join, all the common attributes are chosen automatically, while in case of inner
Automatically, yeah.
join,
In
we
case of
specify
inner
the
join, you get to
attribute.
specify. So what
Okay,
is
ma'am.
that syntax that you have to write? R inner join S on, then you write the equivalence, right? That these two attributes I'm equating.
Yes, ma'am, got it.
So
Okay.
just one question, ma'am. I'm sorry. Can you just then clarify that mock quiz? One of the questions was asked on a left outer join. So I thought the answer was a little weird. Could you just? I mean, you can do it now, or you
Mock,
can do
I
it
don't
later
have
also.
the PDF. I
Okay, fair
think
enough.
Piyush sir told me that he is going to discuss the entire mock in his revision session. Anyways, if you have that question, okay, just all of those questions you have doubt in, just keep them. I will take all of them in the end. Okay, I just want to cover all the topics first. Okay,
Sure.
then I'll
But
take the doubt.
just to clarify, left outer join, basically all the tables on the
Matching
left
values
that matching values. Other than that, all the other values also in that table,
present
right?
in the left table. Yeah.
Left table, yeah. Okay,
And in right outer join is just the opposite. So all the matching values plus whatever is left in the right table.
sure. Now, if there are no matching values, I assume everything on the left table will be
Yeah,
there.
everything on the left table will be there with null values, corresponding null values
Yeah. So the number of rows will be the number of rows of the left table.
of the left table. Correct.
Thank you.
We have one such question also, that if we have three tables each having this many rows, and if we perform a right outer join or a left outer join, what is the maximum number of rows that we might get in the result? So that's a very good question. I have that here. Just wait till
Yeah.
get to all of them. Okay.
Sure, sure.
So
Thank you.
this is the result. So we have all these three matching rows, and then we have two rows from the left table which did not have a match, so we have null in those in the D attribute. Okay. Okay. See this. This is from relational algebra. That is saying consider the relational schema company which has three attributes: name, area, and city, and project has PID, budget, and location. So the domain of attributes city and location is the same. So that basically means that one of them is the foreign key, right? Now, Indian, so these two attributes contain Indian cities. So which of the relational algebra expression would list all cities that are common in company and project? So we want to find the cities which are common in these two attributes in both the tables, right? So in company table you have city, in project table you have location, but these two have the same domain of values, that is city names. So which cities are common in both? Which expression will evaluate that?
C.
And third one.
Third option.
Third C
Third
option.
option. Okay. Any other guesses?
Ma'am,
Fourth,
Everybody
option
ma'am.
agrees?
D.
D.
It's intersection.
So it is, this is basically what? This is the intersection operation, right? If we have R intersect S, then this is the relational algebra expression for it. See how this is correct. First of all, if I take city company, do I have this? Yeah, this is better written. See, if I take option one, right, union, obviously it will result in cities that are present in both or either of them, right, all of the cities. Then if I do a negation or a difference, it will just do result in cities that are present in company but not in project. In the third option that you people said, so here, first tell me, if you do a natural join, is there a common attribute here? I don't know what is the domain. I will look at the attribute name. Are there any common attributes between these two tables?
No, ma'am.
So
No.
natural join will give zero rows, right?
Ma'am, in the last instructor session, sir said
Hmm.
that if natural join is performed and no common attributes, then it will be Cartesian product with all the rows returned, ma'am, which is true.
Natural join, if you do it, should return zero records, right? Because see here, oh, okay, you're saying like if I do exact table natural join, like company natural join project without any projection,
Yes, ma'am.
Yes, ma'am.
yeah, that will return just the cross product. But here we are doing projection first. Na? See, first we are taking city from company and location from project. But since these two are not the same attribute, so here the natural join will give only zero records, right? Because I don't know the domain. I am just saying that these are not same attributes. One is called city, one is called location. Okay, but in
Only
case
in case of direct table
if I
join.
just write company natural join project, okay, here if you don't have anything in common, then it will just be a cross product. Okay, but here we have the projection, so it is just taking the projection, that is taking city attribute from company, location attribute from project, and then doing the natural join of these two, right? So that is nothing in common in these two, right? City and location are different here, even though they have the same domain, but the computer doesn't know that. So 0 records will be produced. So in this case, everyone will be looking at an intersection, right? So intersection is just represented by this. This is the actual relational algebra expression for intersection. So how this works is, see, first it will take, first let's do whatever is inside the inner query, that is this part. So what will this give you? If I do a subtraction between this.
Uncommon entries.
So if I take city from company and location from project, and I subtract location from city, so it will subtract everything that is in common between them, right? So this inner query will result in those cities which are present in only city attribute, not in location attribute. Is that correct?
Yes, ma'am.
If city
Yes,
has
ma'am.
city and location, right? If city has A, B, C and location has A and B, and I do subtraction between these two, then what will be left? C, right? Then now you have a list of cities which are present in city but not in location. So if you take that out of the actual city attribute, then what will you be left with? Whatever is in common between the two. So if I here in this example, since I have C, right? This comes from the inner query, this part. Now if I take this C out of the actual city attribute, that is city ABC, if I take C out of this, then A and B I am left with, which is common between both city and location. So this is the intersection of these two, right? Do you have a
Yes,
doubt
ma'am.
in this?
Yes,
Anyone
ma'am.
has a doubt? So first you take out those which are common. Okay, so I'm left with the ones that are not in common. And then those values I will take out from the original table. So if I take out the values which are not in common, I am left with the values which are in common. So that's the intersection. Okay, this question has 3 marks also. So if you are familiar with, this is why I did that relational algebra expression for division operation, because sometimes instead of writing just the operator, you might be given the relational algebra expression. Now if you were already familiar with it, you wouldn't have to solve this question also. You can just look at it and see that this is equivalent to intersection, right? So this will just take you a few seconds. Okay, this is a bigger question. This, is it readable?
Yes, ma'am.
Yes.
Ma'am. Okay, first read this properly. Okay. So it is saying that I have a relation called G20 where we have country name, foreign minister name, events, date, venue, right? Now there are 3 questions. First is asking I need to find the name of foreign ministers whose names start with J and have at least 5 characters. So first you tell me, if I just write it using that like operator, name starts with J means I will first place J inside of the quotes. Then at least 5 characters means how many dashes after this?
Four
Four
underscores.
underscore,
B, option
Four
B, ma'am.
dashes and then
then
percentage sign.
Then
percentage.
percentage, right? So this is what I should have for the first one, for foreign minister name. Second question is asking find out the number of events taking place in venue gift city. Something, this is the city name, right? So this is the venue. So for this, I need to find out how many events are taking place. So what operator will I use?
Count.
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 Count. So count aggregation operation will be used since I need to find out the number of events. For third question, it is saying find out the venue name and number of events taking place in each venue. So here, what clause will be used?
Group
Group
by.
by.
Group by. If you know these 3 things, okay. Now we have given you a list of queries. So you have to find out which are the correct ones. So for question 1, that is foreign
B.
minister names whose names start with J have at least 5 characters. So
B.
Yeah, okay. B is correct, but let's go through all of them and eliminate actually. So first one, if I take select foreign minister name from G20, where so what is missing in this? The percentage. So this is definitely wrong. This means what? Starts with J and exactly 5 characters, right? So this is wrong. Second one is correct. It matches with ours. Now C is saying select count events from G20 where venue is gift city. Is this correct?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Is there any need to write this using group by?
No, ma'am.
No,
Because
ma'am.
there is only one
No,
venue.
ma'am.
Right, there is only one venue and we are specifying that. So C is okay. Now, if I write E, select venue, count events from G20, group by venue. Is this correct for the third question?
Yes, ma'am.
Yes, ma'am.
So this is correct. Now look at this. These are the 6 options that were given to me. Now, whatever I have done, that I have found 3 correct options. Is there any other option which is also correct for any of the questions?
No.
Option D.
Okay, so you're saying that option
If we
D.
do group,
Sorry,
then it will
for
return
But
only one
ma'am, there is
value. No?
only one value of one venue, and why we need to
If
group
we
by
group,
venue then?
Okay, so you're saying that if I write this group by venue, it will give a wrong result.
it will group by and give only one unique venue name right now. It will group all of them together.
Maybe it
Okay,
won't affect, I guess.
but remember this is an MS key. Okay,
Because
that's why
when
I
you
asked this
once
question.
present after select, it will not like it will give error.
Okay, so let's see what is the correct explanation. Let's take the first option. So 1A. Obviously 1A is wrong. So first option and third option I can eliminate, right?
I have one question on one A. Like it has four underscore right after J, which means like starting with J and four character. A
Yeah,
percentage represents, n number of characters, right? So I mean, we do. I think one A is correct, isn't it?
but what are we asking? At least 5 characters.
Okay, sorry. At least right.
Okay, so
Okay,
it can
sorry.
be
I
5
got
and more. So
more.
that's why the
Okay, got it.
percentage.
Yeah. Thanks.
So 1A is present in 2 of the options, so I can directly eliminate them. Right. Now let's check the other 2 options. So if I take 1B, 2C, 3E. So 1 with this, 2 with C, and 3 with E. Is this correct?
Yes, ma'am.
Yes, ma'am.
See, there is one more option which says 1B, 2D, 3E. Is this one correct or not?
Yes, ma'am.
No, because group
Okay.
by will return only one value.
So we have 2 options, either it is correct or not. Now let's see the explanation, right? So find out the number of events taking place in venue gift city. Both C and D will give the same and required output. See, whether I use the gift group by clause or not. What is the question asking? That we need to find out the number of events taking place in gift city. So here, both of these queries will give me that number of events, right, in gift city. In one of them, I'm writing group by winner. In one of them, I'm not writing it, but I'm still getting my desired result. I'm still getting the events from that particular city.
Ma'am, won't it give error because the venue is not mentioned after the select?
Uh,
As
Select
the previous
count events.
sir told, if you are
There
using group
should
by,
be there should be one comma venue here.
yes.
Yeah, it is not present in the select clause. So that can be an error. Yeah, if it is not present in the select clause, then it's wrong. Whatever we use in group by should be present in the select clause. But if I say that it is present in the select clause, then this option is also equivalent to the third option. Okay, so group by is not an issue here. Yeah, this is a good observation that venue is not present in select clause. So whatever attributes we use in group by must always be in the select clause. So in that respect, this option is wrong. Okay, if venue is not present. But if venue was present in select clause, then it is fine. You can write group by venue because you're still getting the number of events. Right. So
But
both of
is it wrong or right?
Yeah, but
That
if we add Venu, then it is correct option. But in the original question, I think this was some type of a mistake. Then maybe later it was corrected that Venu was added to select clause. But this was an MCQ because of this, that both B and D are correct. Okay, that means the point of this is that question 2 can relate to both these options, C and D. They are exactly equivalent if Venu is in the select clause also. Okay, but syntactically this is wrong. If I remove Venu, this becomes wrong. So in this question, let's consider that Venu is there in select. Then you can take either C or D corresponding to question 2. Okay. Alright, this one. The two relations R and S. So X is the number of columns and Y is the number of rows of R natural join S. So what is the value of X plus Y? Natural join, what happens? So both of these are having same number of attributes and all the attributes are in common. So in natural join, do I have duplicate attributes? Natural join. So X will be what? Number of columns will be after natural join?
3.
3.
3.
What will be the number of rows?
0.
0.
Because none of these are common, right? So when I take natural join, I have to take the whole set, this entire tuple. So 090, not present anywhere here. Similarly for these two rows. So X plus Y will be what?
Ma'am, how we got columns 3?
Because when we do natural join, right? So if I had two tables like this, A, B, C and C, D, E. If I do natural join between these two tables, then what will be my resultant set of attributes? What will be
A,
the
B,
set?
C, D, E.
A, B, C, D, E. So C is not duplicated. In case of inner join or cross join, it gets duplicated, right? So we take, if this is R table, if this is S table, so we write R dot C, S dot C. But in case of natural join, we only take one attribute, right? The C will come only once. So since here all three attributes are common in both tables, so we will just take them each
Ma'am,
one
but the
by one.
elements in the attributes are not same. No? Just
That
the
doesn't
column
matter,
name
no?
is same.
That, see, one more thing. This is not a set union. Okay, so we are not bothered about what is the domain. This is not a set operation. So natural join, when I'm doing, I look at the attributes themselves. So are there any common attributes? So all three are common.
Okay,
Right,
ma'am.
but
We should just
there
see
are,
the attribute name
yeah,
heading.
we see the attribute name. Now, even if you take that, okay, if you take the entire three attributes together in table R, so 090 won't have a match there. Any of them won't have a match. Because especially this B attribute, the domain is totally different. So it won't ever find a match. But there will be three columns, right? So X plus Y will give you what?
3.
3.
And what will that comprise of?
Columns.
Just column name, no tuple.
So nothing is common, so it will have nothing.
Ma'am, someone in
Won't
chat.
it be like R dot D and S dot B column like that?
No, no, that is in inner join or cross join. Okay.
Ma'am, what
In
is the
case of
rule?
natural join, the rule is that if there are common attributes, they appear only once in the result.
So basically two columns will be there, right?
Oh wait, I think I have the detailed solution for
Ma'am,
you.
so
Let
why will
me
it be
find that.
0?
Yeah, yeah, there will be no matches. No, Y is the number of rows. But still, let me just get the actual solution once. I think I have that. Just a second. Yeah. Should I share the solution with you? Do you want that?
Yes, ma'am. Yes, ma'am. Yeah, ma'am.
Okay. Just give me a second now because this is a PDF, so I cannot paste here. Okay, I'll just open a Word file and I'll paste the solution. Okay, see this. This is visible?
Yes, ma'am.
Okay, so
Yes,
this is
ma'am.
the solution that was given for students. So natural join means this bow tie symbol, and natural join will be the tables based on common attributes between the tables. So A, B, C all are common, but there are no matching rows. So it will result in empty set, but there will be three columns, right, corresponding to three matching attributes. So 0 plus 3, our answer will be 3. There will be no rows in the table. Okay. Now see why we say that when there is nothing in common, then we have the cross product, right? But here something is in common. That's why we don't have the cross product here. But how natural join works is first it forms the cross product. From there it gets the matching rows, right? But it is only supposed to show the matching rows. It won't show you the cross product. So someone asked in the previous question, right, that if we have natural join without any matching columns, then what happens? Then we just get a cross product. But here the columns are matching, but the values aren't. That's why it is 3 columns but 0 rows. Clear for everyone?
Ma'am, in what case they will do cross join?
Whenever natural join, we are doing natural join for any two tables, right? So the first step to do is find the cross product. After you find the cross product, then you check the matching values in the two columns. So wherever the values match, you take those records and you show them in the actual natural join result. Except what you do is you don't show the duplicate columns twice, you show them just once. Okay, so how it works step by step is first you do the cross join, then you place the condition. Okay, but in the natural join result, that cross join won't be showed, especially in this case since we have common attributes. So that means something will be present in the result, that is just the attribute names, but nothing in the actual rows. Okay.
Ma'am, can you solve this?
See, if I take natural join of these, so obviously in answer, I'll have three attributes A, B, and C, which are in common, right? No duplicates, so they only appear once. So you have to take all three attributes together. So this will come 0, 9, 0. So you find a match for 0, 9, 0 in this S table. Is there a match?
0 cat 0. But
B column is not
9,
matching.
yes,
All of
yes.
them have to match together. So
Okay.
in this case, that will never happen because the B column has totally different domain of values in S table. Right?
Okay.
So that's why 0 rows will come in the result, but columns will be there. It will just be an empty structure at ABC, but no values.
Ma'am, what if it was ABC and DEF?
ABC and DEF, then also you will take just whatever is common, right? So ABC will appear once and then the DEF columns, but still there are no values. You cannot find a match, right? You can only show those tuples which have a match.
So number of columns would be 6 then?
Yeah, then number of columns will change. But still rows will be 0 only.
Now, won't it be a cross product if ABC and DEF will be?
Why will it be cross product? Cross product is how you solve for natural join. Okay. But in the result, what do you show? Whatever match you can find. So if I had two tables like this, ABC, CDE. Okay.
No, let's suppose DEF. Then natural join will perform cross product or it will
If you
return.
have ABC and DEF, this is what you're asking.
Yes, yes.
Yeah, then it's just a simple cross product since nothing is in common. So nothing will be there. In case of natural, you cannot perform natural join in such a table. It will just be a simple cross product.
No, if we
So
query.
how many columns will be there? 0?
Yeah, this won't show anything.
Okay, if we perform natural join by the query tool, it will not perform anything.
No, this won't do anything because there is nothing in common.
Okay.
That the way we solve for natural join is an internal procedure, right? It won't show you that. It will just give you the result. If there is nothing in common, it won't give anything. At least some attribute has to be in common. Okay, here that is the case. These three attributes are in common in both the tables, but there are no matching values. That's why 0 rows, but still there are three attributes.
So in this sense, it will it will prepare the columns
Yeah.
based on the join, but when it tries to do the actual
Join itself.
row-wise
Yeah.
comparison, the result set will have
Null.
empty values, because null values, because 0, 9, 0, 0 and 0, 9 and cat, and
Yeah,
0 and
exactly.
0
That's how it's
will
meant.
evaluate as false. So
Yeah, because see,
it
this
will come
B
empty.
column has totally different domain, no? So it won't match for any of them. There is no point in even checking because this B and this B are never going to match. Okay, so it will, what this will give is just an empty structure of a table containing A, B, and C. So X value will be 3, but Y value will be 0. 3 plus 0, the answer will be 3 for this. This is an NAtive type question.
Excuse me, ma'am.
Hmm.
Ma'am, in case of two different, completely different relations like A, B, C, and D, E, F,
Hmm.
so can we say that the natural join is impossible to do?
Yeah, it is not possible.
So it will not. I mean, it's not even able. We can't even execute it. Like we won't even get any relation or any schema for that
If you
result.
try to create two tables like this on Postgres and you try to do natural join, it won't give you anything in result. It will be an error like there is nothing in common, so natural join can't be executed.
No, no, ma'am. We actually checked in PG admin for this question.
Is it
Where
giving?
ABC and DEF, it
Yeah,
gave
it's
the
giving
cross
the cross
join.
product. Yeah, it will give the
Give
cross
the cross
product maybe.
product.
I think in MySQL or somewhere it shows that error.
Yes, ma'am. Some versions it is not coming up, but we checked in PG
Okay,
admin.
so
It is
PG
coming.
admin gives you the initial step that it performs the cross join, but there is nothing to match. Yeah, that is okay. Okay.
Ma'am, I got confused now after so much discussion. So when we have extra D column here, so will
Okay,
it?
let me just tell you what is necessary important here. Okay, first thing is that if you have a natural join, fine, it will only execute when you have at least one common attribute between the two tables. Okay, now even if you have all common attributes but no matching values, then you will have 0 records in your table, but you will still have the structure of the table. Okay, in case of inner join or cross join, what happens? Inner join, you specify a common attribute, so obviously here you cannot do that. Inner join is not possible here. If you have A, B, C, and D, E, F, then you cannot equate anything, right? In case of cross join, what happens? If I do a cross join of these two tables R and S given here, A, B, C, A, B, C, so it will give me 6 total columns in my result. The first set of ABC coming from R table, second set coming from S table. In case of natural join, it will only give the duplicates once. So since here all of the columns are duplicates, A is present in both tables, B is present in both, C is present in both. So ABC will appear only once. Okay. But since there are no matching records, nothing is common in the value, right? ABC value in R table and ABC value in S table, no common tuples are there. So there will be 0 rows. But the structure is still there. 3 columns will be there with nothing to show in the records. So it is 3
Okay,
plus
ma'am.
0.
Thank you.
Ma'am,
Hmm.
actually, this same question is in the AQ 2.2 question 5.
Hmm.
But there they are saying that union is not possible. Like the operation is not possible.
Union is different, no? Union and natural join. Union checks what? There is a union compatibility rule where you have to check the domains also. So here union is definitely not possible because B has a separate domain. In union, your number of attributes have to match and your domains also have to match. So if the question was if R union S is possible, it's definitely no. Because B's domain in R table is integer, here it is some string. Okay. So union, intersection, those are different rules, and natural join is a separate rule. Okay, those are set operations. For union and intersection, you have the compatibility rules. I think those were discussed in week 2 or 3. Okay, so you can go over them once.
Ma'am, then in case of union or set operation, it must be the same, right, ma'am? Domain.
Yeah, the domain of the attributes should be equivalent. Okay, and even if there is one table having A, B, C, another table having C, D, E, F, 4 columns, that is also not union compatible. Both tables must have same number of columns. Okay, you can check out, I think, my last term lecture in week 4 where we discussed set operations. So I discussed all of them, union, all, compatibility rules, except all, everything is there. Okay, or if it was discussed this term, so you can check that lecture also. I don't remember discussing this term. Okay. Okay. Now see, this type of questions don't get confused so much. Okay, you don't have to worry about what Postgres is going to show, what MySQL is going to show. You just have to remember what is the rule of natural join. If I apply that here, what will happen? Simple thing. You know that natural join takes the common attributes only once. So how many common attributes are there? 3. So 3 attributes will be there, right? Here, since all the attributes are in common, so only those attributes will come once. But there are no matching records, so 0 rows. Simple as that. 3 plus 0, 3. Okay. Now, this is a very good question. See, everyone knows on delete cascade. Anyone who doesn't know?
No, ma'am.
No, ma'am.
Was this discussed on delete cascade? Okay. Okay, no problem. See, I'll tell you. What happens is, let's say, okay, I'm taking this question only for example. Let's say I have this table, okay. So what is given that I have 4 attributes A, B, C, D, where A is the primary key and C is the foreign key referencing A. So this C attribute is a foreign key in this table only, which is referencing the attribute A. That means what? C's domain should be what?
A.
A. So it should not assume any values which is not there in A.
Yes.
Correct. Now, if I subtract a particular value from A, right? If I take out this 1 from A, if I remove it, then which rows in C will have to be removed?
Last,
Wherever 1 is present. So basically I have to take out this entire 2 rows, right?
Yes.
If I remove this first row, then I have to remove these 2 rows also. Okay, this is on delete cascade. Means if I remove something, if I delete something and it leads to deleting some other things because of this referential integrity, that the domain must be the same. That is, if 1 is not present in A, then 1 cannot be present in C because C is foreign key referencing A. Okay, now can you tell me that if I delete these 2 rows, what other A values are getting deleted? 6 and 7. They are also getting deleted. So are these 2 values anywhere present in C attribute?
No.
Yeah, 7.
6 or 7?
Yes, ma'am.
7
7
is
is
present.
present.
7 is present.
That means this corresponding row also has to be deleted. Now that means you also removed 8.
It
Is
is
8
not
present
present.
anywhere? No.
8
So we
will
will
not.
stop here. Right. So we will just stop here. So now
ma'am,
it
why
is.
we delete the whole row? Can't we delete the one element and it
No,
can't
this is
be
actually the
null?
question. Okay, this is the question. So see, the question is asking that how many tuples will be left in the table if the first tuple is deleted. That is,
Okay, so
entire row is deleted.
if they mention not tuple
No,
and
no,
only
no. That we don't do. Then it will just be null values throughout the table. No.
okay.
You either delete an entire tuple or you don't. Some particular cases might be there where you might want to delete a particular value. But in this type of questions, we will mainly be focusing on the entire tuple, not a single value.
No,
Okay.
no, I am asking, is it possible for the single value as
Yeah,
if
if
we
you
delete,
remove just 1, then also this will be a violation. Then also 1 has to be removed from C attribute.
uh, but then if we only delete one from the C attribute, then we
Then
won't
no,
have to
we don't need
delete.
to remove anything from A because it is not present in C. A is the primary key.
Yeah,
C is the foreign key. So C is referencing A, not the other way around. So if something is deleted from A, which is present in C, that has to be deleted.
yeah, I
C, I
am.
can delete anything. It won't affect A.
No, as in this question, if we delete one from the C, the whole tuple gets deleted, right?
Yeah, yeah. Here
But
too, we are talking about the only the tuples, not singular values.
yeah, but in case of singular value, if we delete one from A, then we have to delete one from C.
Yes.
The both last and second last value from C
All wherever one is present. Yeah.
will get deleted, but it will not affect A, right?
No.
So it will stop there only.
Yeah, it will stop there only since no other values are getting deleted from A.
And it
If
will
you work
become
with
null
single,
in the place of 1. Is it?
yeah, it will just there will be nothing present, null value. Right.
Ma'am, but when the foreign key of 1 is removed, the primary key of 6 and 7 is also going off. So there will be a cascading effect, no ma'am?
Yeah, that's why it's called on delete cascade. So first, see, the question is asking 1156 is deleted. That is the first row. Now on delete cascade is applied over this table, then how many tuples will be left? So since the 1A value is deleted, so these two rows have to be deleted as well, these two tuples. When I delete these two tuples, I'm losing these two A values, 6 and 7. So wherever C contains 6 or 7, those tuples have to be deleted also. 7 is present in this row, so this entire tuple has to be deleted. Now I lose the 8A value also, but 8 is not present anywhere in C. So there is no more chance of deleting anything. So how many tuples am I left with after all the deletions?
4.
4. That's the answer.
Ma'am, is it possible to have a foreign key and primary key in the same table?
Yeah, it can be. You can have a table referencing itself also. Okay.
Self-referencing tables are allowed, no ma'am?
Okay.
I can just write referencing the same table, right? So whatever is my primary key in that table, I can reference the values from there. But usually it is not very useful.
Until and
I mean,
unless you
usually
want to do linked list, no ma'am?
yeah, that is one scenario. Yeah, right. That's one good example. Linked list can be done this that way.
Ma'am, in question, always it will be given which row is to be deleted.
Like whenever we have these on delete cascade questions, right? Mainly you will be told about an entire tuple, that this tuple is deleted. So what effect will it have if I apply on delete cascade?
It will
So
be
what are the rows? Yeah, it will be given. The tuple that you want to remove will be given. Like here 1156. After that, you have to find out what other tuples are getting deleted because of it.
Ma'am, always there will be only one row or one more
No,
than.
no, there can be more than one. Okay, I can delete two tuples and tell you what effect is this having.
Okay.
Ma'am, why are we deleting third row?
Because we deleted these two rows, no? So here, what are the A values that got deleted? 6 and 7. But this 7A value is present in the third row. So if it is not present in A, it cannot be present in C. So it has to be deleted too. Okay.
Ma'am, answer is 4 now.
Answer is 4. Yeah, these 4 tuples will be remaining. Is this clear? Anyone has any doubt? This is an important topic.
Ma'am, this concept is of week 2 now.
Yeah, I think. I don't know if it was discussed or not. Anyways, on delete cascade means since this is a cascading effect, that is one delete is creating a lot more delete operations. It is wherever you are deleting a unique A value, you have to find whether that A value is present in any other tuple in the foreign key. Because foreign key cannot have any values which are not present in the actual attribute that is being referenced, in this case A. That causes referential integrity violation. Right. So that's why 7 is being removed here. So 7 is present in third row. So this also has to be removed. But 8 is being removed in the third row as A value. But 8 is not present anywhere in C attribute, right? So no more deletions are needed. Okay, clear. Should we go to the next one? Okay. See. Just look at this schema. Okay. So we have 3. This is a very good question. This is what I was talking about. So we have 3 tables: product, order, and users. Okay. So can you tell me what are the foreign keys? In orders table, what are the
Product
foreign keys?
ID and user ID.
Product ID and user ID.
Yes.
Right. So this question is asking if the relations order, product, and users have 10, 6, and 8 rows. So what is the maximum number of rows that will be returned by the following query? Okay, this is the query. Select star from orders, right outer join users. This is the query. Okay, so it is asking that what is the maximum number of rows that might be returned. So consider that every attribute is having not null constraints, so values are present in every attribute.
10.
Okay, 10, someone is saying. Any other answers?
8.
Eight. Oh, yeah, eight. Sorry, right. I've taken left.
Ma'am, it's a
Right.
right outer join, right?
Yeah, it's right
So
out of
Yeah,
join.
yeah.
if since 10 records will have not null in
All of them are not
order,
null. All attributes are not null.
yeah, so the 10 and they will somehow be mapped to all the
First, see, ordered table has how many rows? 10. Users has how many rows? 8. Who is this person? Anyone see who is this? I have to report this. Okay, I've got a screenshot. You either mute yourself or please leave the meeting. This is not a joke. Same thing has happened in other sessions also, and we have taken disciplinary actions against such students, okay? So please don't treat this lightly. Please mute. Everyone will be muted. Okay. So ordered table has how many rows? 10, right? And users has how many rows? 8. So I am doing a right outer join with orders as my left table. Just give
Ma'am,
me.
mute all.
I cannot mute everyone in this call. Okay, so I have to join from another ID. Please give me 2 minutes. Okay. This type of people just disrupt the entire class.
I think it is coming from Lakshmi.
Yeah, just do one thing. Not someone, please just send his name in the chat box so I can send it to the team. Let me check if I can remove them.
Mic is off. Like her mic is off now.
Okay. See, this just disrupts the entire atmosphere. This is.
Ma'am,
Okay.
if I may.
Hmm.
So here, once you have that note in the bracket where you mentioned that
Hmm.
not null constraints, there are no attributes rather that have not null constraints.
All attributes are
So
having not
all
null
attributes
constraints.
have, sorry. So that means they'll have some property, right? Something
Some
will be
value
there.
will
You
be
want,
present in every attribute.
yeah. So that would mean any so there is no need of an on thing, right? Like on so and so join and all need not be mentioned. Just write out a join and you can assume everything
No,
corresponding
whenever
to
you
that
write
number of
right
rows.
outer join or left outer join, you don't have to give it that thing.
Yeah, I'm sure that's right, but I'm just saying even without that, once you have this not null that constraint and you have this right outer join given with the corresponding users, so then it's like a sure shot thing where the users will have 8 rows.
Yes, users will have 8 rows.
Yeah.
Okay,
And
now
how many columns
important
will
thing
there be,
here
ma'am?
is I have a lot of problems. Let's see how many we can complete. Otherwise, I'll just upload this entire
No, ma'am.
PDF.
My doubt is how many columns will be there in
Okay, columns. Okay, yeah. See, right outer join means so you will take since this is outer join. That means the
So
duplicate columns will be showing.
user ID is the common column,
Yeah.
isn't?
So once the user ID will be coming from users table, once from order table also. But see, that will not be relevant. See, why, how to solve this type of question? First of all, you see orders has how many rows? 10. Users has how many rows? 8. Now I need to find what is the maximum number of rows that I can get from this right outer join. So when is the maximum going to occur? First tell me, what is the maximum
All
number
the
of
orders
matches
are
that I
from
can
one
get?
user, ma'am. When
Ma'am,
all the
18
orders are
can
from
be
one
18 also, the
user,
answer.
Correct.
Ma'am,
So when all
15.
the
18
orders
can
are
be
from
answer.
one user. Yeah, sorry.
Ma'am,
Ma'am,
18 is 18 the right answer?
No, 18 is not the right
15,
answer.
ma'am, 15.
No. 18 is
No.
close.
10 plus 7, ma'am.
Yes, 10 plus 7. So how this happens, see, whoever answered this is correct, that order every if one user places all the orders. Okay, in that case what happens? So let's say users table has user ID column, right? So there are 8 distinct values, definitely, since it's the primary key. Okay. Now in orders table, this user ID is a foreign key, right? So when I am doing this right outer join between these two, this user ID is the attribute based on which I am doing the right outer join. So if the user ID 1 has placed all of the orders, so how many matching rows will I find? Just the matching rows, tell me. There are 10
10,
rows in
ma'am.
10
order.
matching.
Okay, so all 10 are placed by user 1. So there are 10 matching rows. Now you have to take everything that is left in the right hand side table. So how many rows are left in right hand side table?
7.
7. So
7.
10 plus 7, 17 is your maximum. Okay.
Ma'am, if it in this case, if it was left outer join, then what would be the answer? 15.
Left outer join, then there are 10 rows here, right? So order ID. Let's take order ID. Okay. Still user ID is the one that we are basing this on. Uh, if I take user
It
ID,
will be 8 plus
orders,
9, ma'am.
let's see. So this user ID is coming from orders. This user ID is coming from users. Now
It will
here
be
the
10,
order
ma'am.
ID can this user ID can be anything, right? But this user ID is fixed, that these are all distinct values. So if I want to find, you want to find maximum number of rows in case of left outer join of these two tables, correct?
It
Yes,
will
ma'am.
be 10, ma'am.
So here the maximum value can be what? If I find all matches, that means every row from the order table should find a match in the user table. So how many rows are there in order table? 10. You cannot have more than that, right? Left outer join means what? Whatever is matching plus what is left in order table. So how many matches can I find at max? 10 matches
Yes, ma'am. Okay,
for
ma'am.
10
Understood.
rows. Nothing else is left. So 10 will be answer for maximum.
Ma'am, can you explain the 17 again, ma'am?
Yeah, see. User ID in users table has all distinct values, right? Since it's primary key. So let's say 1, 2, 3, 4, 5, 6, 7, 8 are the 8 different user IDs. Now, users table is the right hand side table and orders table is the left hand side table. So right outer join means we will take the matching values and whatever is left in the right table. Correct. So if user 1 placed all of the orders in orders table, so how many times will the user ID match? 10 times. 10 rows in order table. If user ID placed all those 10 orders. So all 10 rows are matching with user ID 1.
Yes.
Then how many user IDs are still left in my right hand side table? 7 user IDs. They will not find a match. So corresponding values will be null, but they still have to be added to the result since it's right outer join. So whatever is remaining in right table you have to add. So total how many rows you're getting? 10 matching rows plus 7 rows from the right table that did not find a match. So 10 plus 7.
Yes, ma'am.
Okay. This is important question. This has come many times.
Ma'am, but even the user which was who ordered will come into primary key, ma'am.
In orders table, user ID is not primary key, no. The same user might have placed 2 or 3 different orders, so the user ID will be same. Primary key has to be unique, right? Order ID is the primary key in orders table.
No, I mean in use there will be the user ID who ordered all the products, right? So even that will come in the right join.
Yes, but that is the match, right? We don't have to take it separately. It has already found matches. Separately, we take those values or those tuples which did not find a match. The other 7 user IDs, they did not find a match. So them I have to include in my result with corresponding null values. For user ID 1, you already found 10 matches. Right. So for all of those tuples, user ID will
Okay,
be
so
1
the
only.
So
Got
ma'am,
it.
to maximize the number of rows, we should have at most one user ID foreign key, right? In
In
the
this case, yeah,
users.
whatever is the foreign key, yeah, whatever is the foreign key, if that matches to only one value from the original referenced attribute, then it is the maximum case.
And what about the minimum, ma'am? Like
Minimum will be when you find,
all
let's say
different.
all of them, yeah, all different. So
Okay,
if
so
you have
then
8 and 10, right?
okay.
So minimum will be when you find 8 matches,
Yes, match.
all 8 matches you are finding.
Mhm.
So two rows are there in the orders table which do not find a match, but this is right outer join. So nothing is left in the right table, right? So 8 will be minimum.
And this right outer join will have how many columns?
Columns is like, when you do this, so columns you have to take duplicates from both tables.
Oh, it takes the duplicates also.
Yeah, it will take duplicates.
And user ID will be two columns or a single column?
No, one user ID from orders, one user ID from users.
Okay.
That single column only happens is in case of natural join. Okay, that removes the duplicates. You can still check the week 4 slides once. There it is given in a very nice form, all the outer joins. Okay. Okay, now solve this one. This is asking an instance of relation students is given below. So which of the following queries executed on this particular table will result in the following output? So I applied some query on this table, relation students, and it gave me figure 4 as the output. So what is that query? Okay, first you look at two tables, both of these tables, then I will give you the options.
Sort
So,
algorithm.
so what can you see, like what stands out in the resultant table? What is there?
Name is sorted
Sorting using the names. Name.
Ordered by name,
Name is
ma'am.
sort. Okay, order by name. Fine. Now check
And
these four. So from here, what do you think is the correct one?
B option.
B. Order by
B.
name.
C, ma'am.
So okay, someone said
B
C.
option.
C, ma'am.
Okay, let's see. If I do just B. Okay. So I'll take everything and I'll order by name. So there are two names, Smith, right? So in which order should these two names come? If I do order by name, then I can take them in any order, right? So I can take
So
this
it will be descending, ma'am.
53688. Yes.
Ascending. Sorry.
In case of just name, right? So that is taking the first alphabet, that is S. So this Smith can come first 53688, then this one 53650. But is that the case in your result? See, first this Smith is coming, which is having 53650, the smaller SID. Then the larger SID comes, 53688. That means what? After I have ordered by name, I have also ordered by the SID. So SID is also in increasing order. So option C is the correct one. Order by both name and SID. First order by name and then order by SID. So if there
Ma'am,
are any common names, you have to order
But
those
ma'am,
common names
in
by the
second
SID.
row it is written that 66.
ma'am, in the SID
In
column,
second.
the first and third entries for the SID
No, no,
in the
no.
result, first
See
and
what
third.
happens. First you have to order by name. Okay. What comes first in the query? Order by name, then SID. So you first order this by name.
Ma'am,
You
yes,
cannot
ma'am.
order by two attributes together, right? One by one.
Ma'am, that's what I'm saying. In the result output relation, the SID is not ordered in ascending order. See,
Hmm.
53832,
Exactly, it's not.
53831. So
But
SID is not there.
no. See, first names are in ascending order. Fine. First I ordered by name. Names are in ascending alphabetical order. Okay.
Right, ma'am.
G, E, J, M, S, S. After that you place the SID. Okay. But remember, we cannot misplace SID, right? If Jones is corresponding to this SID in the original table, it must maintain this. Otherwise the relation doesn't make any sense if I change this. SID is let's the primary key of this relation. I cannot change SIDs for different names, right? It has to maintain that.
Right.
But
Ma'am, I
after I
guess in
ordered
class
with
it was
this,
said like the SID will be same order if the names are same like that.
see,
They'll
Yeah,
come
if
in
after
the
you
same
order
order
by
order as they
name,
were in the
if there are
original.
two, if there are two
if the order
same
is
names,
not name, then go ahead. Go ahead. My
if
apologies.
there are no similar names, if all names are different, then no need to do this SID. Okay, order by SID, order by name is okay. But since there are two same names here, Smith, right? So after that, when I place the order by SID, that constraint, then it will check the one which has the lower SID first. That will come first, then the higher SID. Just for these two names which are similar. Okay. So this Smith has the lower SID 53650. So his row will appear first in the result. Then this second one, which is the higher SID. So first you order by name, then you order by SID. So that SID constraint will only be placed on those rows which are having same names or duplicate names. Okay.
Just as a academic exercise, what if we just order by name without giving the SID? In which case, the 88 will come first, followed by
Yeah, yeah.
50.
Whatever
Okay.
is there,
Okay.
it will come.
Thank you.
Okay. Is this question clear for everyone? Anyone has any doubt? Option
No,
C is
ma'am.
the correct answer.
Understood, ma'am.
Okay. Now this one. This is easy question. See, what is the number of tuples returned by the following relational algebra expression? So first in student table, what we are placing is a selection condition, marks greater than 50, and then whoever has marks greater than 50, we are projecting their names. Okay, so how many tuples will be returned?
6, ma'am.
So how many people have scored greater than 50? Rakesh has scored. Pranav has scored. This Rakesh has also scored. Emily, Grace, Lily. So there are total 6. But will 6 be returned?
No.
What are these operations?
No, ma'am.
Five,
Project
No,
ma'am.
ma'am. Only 5.
no duplicates, right? So Rakesh will only appear once. So 5 rows will be returned. See, this is easy, but still there is a chance of getting it wrong.
So what will be the marks shown for Rakesh?
Marks are not being shown, na? You're only projecting the name.
Okay.
Yeah.
And if it said Rakesh name and marks, then what will be?
Then you take the combination. Then combination is unique. Rakesh 65 and Rakesh 99 are unique combinations. Both will be shown. But if I take just the name, then it becomes a duplicate.
Ma'am, what if Rakesh has one subject lower than 50 and one subject higher than 50? Will it show?
Here the subject wise division is not given, na? Only
Okay.
marks.
Yes.
Okay,
No,
this
if
totally depends on what the table is.
If Rakesh had less than 50, then it's not considered, isn't it? Yes. One less than 50 and one.
No. Even if one is more than 6, if one is more than 50, that will be considered.
Okay.
Okay. But if both are more than 50, then only one time the name will be shown.
Ma'am, the result is set for both relational algebra and calculus, right, ma'am?
Come again?
The result is a set for both relational algebra and calculus, right, ma'am?
Yeah. So these are, see, these projection operations, these always take only the unique values. Okay. That is the only difficult part in this question. So everyone will first think it's 6. If you're careful, you'll see that there is a repeated value. So that will only appear once. Okay, this one. Consider the student relation. Select the correct query or queries. This is an MSQ to obtain the last name of students whose age is more than 25. So there are all mixed relational algebra is there, TRC is there, DRC is there. So which options are correct?
Ma'am,
First,
C.
see what can you first this type of question. Let's try it my way. So what can you eliminate immediately? Can I place any kind of arithmetic operator to projection?
Option B can be eliminated.
Option second option.
Because I cannot place
Option.
conditions on projection. So this is eliminated. Is option
It's
A
the
correct?
third option is correct.
Okay, third option is correct. Yeah, because first we place the age constraint, then
Ma'am,
we
A
take the
is
last.
eliminated.
So
C is
is
correct.
the last option.
Last option, ma'am. As
Why
well.
is A
No, T
eliminated?
dot L name. S dot L name. Yeah, I think the last option is also correct.
Last option also.
Last one is also correct. Because this is a simple DRC query. So you have S as the object of student, S dot age should be greater than 25, and T dot L name equals to S dot L name. So we are projecting the last name. This is fine. Is the first one correct or not?
Yes.
No. No, no.
Why this is not
Since
correct?
we have not mentioned.
T dot.
We are not mentioning T
Syntactically
dot L.
incorrect.
What we have not mentioned?
That
Ma'am,
last.
Ma'am,
syntax is
I think
incorrect.
it's correct
It's a
because we
correct
are
option.
saying student of T
Yeah.
in the
So you
bracket.
can write it like this also.
Student of T is mentioned, ma'am.
So T is the object for student table, and we have to say that T dot age is greater than 25 when you're projecting T dot LM. This is also correct.
This is correct. This is
All three
correct,
are
ma'am.
correct except for option B.
Ma'am, T indicates the
Yeah, I
tuple.
call it like, yeah, it's called the tuple only. But whenever I teach this TRC DRC part, I call it that relationship object because this T represents every tuple in the relationship, right? So we take those tuples where the condition is correct. That is, age is greater than 25. And now from T tuple, you can project whatever column you want. So T dot LM. So all ACD are correct except for B. Okay, this one. This I have solved. Okay, so you should be able to answer this. First, see. Consider the following relation university. Okay, three tables are there: student, takes, and course. The student is student information, course is course information. Takes is what uh, basically combines these two tables. So it has one attribute ID coming from student, one attribute ID coming from course. So which student takes what course? The question is, which of the following queries returns the ID and name of students who have taken all courses offered by the biology department? So I have removed one of the options. So here among these three options, the correct one is there. Okay, I'll just.
Ma'am, can you explain the question again, the ID part?
It returns the ID and name of the students who have taken
No,
all
no,
courses
the
offered by
table.
biology. Yeah, this
Student.
this ID is the primary key of student table, and this course ID is the primary key of course table. In
Okay.
takes table, ID is the foreign key that is coming from students table, and course
Student.
ID is also foreign key coming from course table. But these two together make the primary key of takes table. Okay. So your job is to find the ID and name of the students who have taken every course that is offered in the biology department. So which of these three are correct? I have also solved this question once. So just try. First option, if you look at it, what is wrong in first option? So you are selecting,
Union.
yeah, that is a union, right?
What is
So
takes,
you are
ma'am?
selecting distinct. Takes is a table which shows that which student ID has taken what course ID. Okay. It has only two columns, ID and course ID. ID coming from students table, course ID coming from course table. So takes table shows you which student is taking what course.
If
So
not exists also doesn't make sense.
now see what is wrong here. So select distinct SID S name, fine, from student as S. So it is saying where not exists. Now I'll
All that
leave
are
this
not
part
by.
for now. Let's check the inner subquery, right? So in the subquery, what is happening? Union between two sets. What are the sets? This is one set, this is one set. What is the first set going to evaluate? Select course ID from course where department name biology means all course IDs in biology department, correct?
Yes.
And what is the second set representing? Select T dot course ID from takes as T where SID equals to TID. For any particular student, it will give all the courses that this student is taking, right? All the course IDs for a particular student T or S, whatever you want to say. So the outer object is S, so outer alias is X, S. So let's say for some student having any ID, this second part of the union, that is the second set, will give all the course IDs for a particular student, that this student is taking all these courses. So let's say some student is taking CS 101, Bio 101, then CS 102. And in biology department, let's say I have only three courses: Bio 101, Bio 102, and Bio 103. These are all the courses in biology department. Now let's say some student is taking these three courses. So if I take a union of these two, what will I get? All the courses, basically,
Everything.
this and this. So should I be showing the student's name? Is he taking all the courses in biology department?
No.
He is only taking one course in bio 101. What about 102, 103? So this student's name will also be shown in this query because we are taking a union. So this is not the correct query. Look at the second one. What is wrong? Look at the
Ma'am,
inner
but it
subquery.
is saying not
Second one
exist.
exists.
Here, okay, not exist. That not exist returns true when? When does not exist return true?
Ma'am, when the subquery is null,
Returning
result
empty
of,
set.
yes.
Okay, so if some student hasn't let's say taken any course, so in that case the union will give what? Just the biology department ones. So for them also their name will also be shown. If some student let's
Okay.
say has taken some course, only CS 101 he has taken, no biology courses. Basically what will happen is not exist will never uh, return true here. Why? Because you are taking a union. So it is just doing union means what? It is kind of adding, right? From both sets I'm adding. So if I'm adding, I'll never get something null because the first set will definitely give me the all the biology course IDs. So something has to cancel that out, right? To get a null. So union will not cancel anything. Union will just take the union of both sets. So not exist will never return true in this case. Actually, this will never give a result. This particular query will never return an SID or SNAME because not exist will never be true. But in the
Okay,
second
ma'am.
query, what is wrong?
Ma'am, if we take union of this two table, that's CS101, Bio 101, CS102, then in union, how many tuples it will get written? 6.
Union takes duplicates or not?
No.
No
In
duplicates.
union all. In union
So
all,
only
it takes
five.
only
So
5.
five will be there. But that's not even relevant here. It doesn't matter because as long as anything is present in the set, not exist will return false. Okay. If not exist return false, then that means nothing will be displayed. No SID, no SNAME. So first option is definitely wrong. Second option, what is wrong? Same thing is happening. This will give all the biology courses. This will give all the courses a particular student has taken. So let's say it is the same set. Some student has taken these courses and these are all the biology courses. Now it is saying except. That means I will subtract these
Subtract.
from this set. Right. So if I subtract, what will I be left with? Bio 101 and Bio 102? I'm sorry, Bio 102 and Bio 103. This Bio 101 will be cancelled out, right?
Yes, ma'am.
So exist will return what? If something exists, exist returns what? True.
Yes, ma'am.
Yes, ma'am.
So even if a student hasn't taken all the biology courses, still their name will be shown in my result because exist will return true. Right? Like in this case, this person only took one biology course, still his name will be shown in the result. So this is also wrong. The third option, is this correct? It has to be correct. It's the only option left. So this one I already discussed once when I was doing week 3, right? When we did discuss those exist not exist clauses. So here what is happening? First inner subquery, first part. It is giving all the biology courses, right? Bio 101. Now let's take an example. So let's say 3 courses in bio it will show first set. These are all the biology courses. Okay. Now this one, let's say for a particular student, this student has taken these courses. He has taken CS 101, Bio 101, Bio 102, these 3 courses. So if I do an except clause now, so difference of this minus this, what will I be left with? Bio
103. Bio 103.
103. So if something is present, then not exist will return what? If something exists, then not exist will give what?
False.
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 So if it gives false, that means this person's ID and name will not be selected, not be displayed. But if some person had taken all 3 courses in bio department, then except clause will do what? It will remove everything from the first set. So we will be returned with what? Null. Nothing is remaining. When I have null, then not exist returns what?
True, ma'am.
True.
So it will return true for those students who have taken all the biology courses. They might have taken other courses too, but they definitely have taken all the biology courses. So for them only I will get a null set. And their not exist will return true, so their name and ID will be displayed. Is it clear?
Yes, ma'am.
Sure,
Yes,
no.
ma'am.
Anyone who has a doubt? Because this is an important question. If you have a doubt, you can ask. Okay.
Excuse me, ma'am.
Yeah.
If you don't mind, can you just explain that option once more, the one which is correct?
Okay. See. First, let's go to the inner subquery. Okay, that is from this bracket to this bracket. So here I can see there is a set operation called except. That means there are 2 sets. This is the first set. So first set is saying what? Select course ID from course where department name is biology. So this will give me what? All course IDs in biology department, right? All the courses that are present in biology.
Yes, ma'am.
So that set I said let it be bio 101, 102, 103.
Okay.
Now the second set, this one, this gives what? Select course ID from text table where the student ID matches. That is for any particular student ID. It will show you all the courses that that particular student ID is taking or enrolled in. Now
Yes,
some
ma'am.
student might be enrolled in all these 4 courses. So this is my second set. Except does what? It is like a set difference. So first set minus second set. So if I take out everything in this set from this set, so I will be left with what? Null. Because this particular student in my example has taken all the biology courses. Right. So first set is completely cancelled out. So we are left with null. Whenever we have null and then we apply not exist on that, that is not exist, then some inner subquery, and the inner subquery evaluates to null. It doesn't have anything. It's a null set. Then in that case, not exist returns true value. Okay, not exist or exist, these two operators always return Boolean values, true or false. So if the set is null, not exist will return true. So in that case, if it returns true, the corresponding student ID and student name will be shown for the same student who has taken all these courses.
Yes, ma'am. Got
Now,
it,
if
ma'am.
a student didn't take a particular course in biology, then that course will be present in the set, right? So
Yes,
not
ma'am.
exist will return false.
Okay.
Ma'am, can you show the question once?
Yeah.
Yes, ma'am. Not able to view screen.
My screen is not visible.
No, while we were solving the question, we were not able to like
Okay, okay,
read
okay.
what was the question asking. So we were not.
The question is just asking for the ID and name of students who have taken all biology courses.
Okay.
Okay.
Now we're.
Is this clear for everyone? Okay, then let's do the next one. This is also a good question. Wait, let me reduce the size of it. You can view the entire question.
Ma'am, you can press F11 to maximize the view area of this PDF.
This one.
F11, key F11.
Okay,
No?
okay. F11. Not working.
Ma'am,
It is
please
saying
click.
like this only.
Please click on that the
Function.
application bar.
Function
Yeah,
plus
yeah.
F11.
Okay. No, still nothing is. Okay, this is okay.
Yes, ma'am. Thank you.
All right. So see, this question is saying that if these 2 tables are there, student and course. Okay, so who was asking about except clause? Someone was asking in the beginning of the session. Okay, anyway, so this is that question. Okay. So these 2 tables are there. How many rows will be returned if I apply this query? So first line of the query is doing what? Select ID from student comma course. What does this mean? Student comma course?
Cross product.
Cartesian product, ma'am.
Right. So how many rows will be there?
20.
20 rows. So you select ID from all of these. Okay, all 20 rows. Now next line is except all, select ID from student. Okay, so how many IDs are there in student table?
5.
5.
20
So
minus 5,
except all
15.
means, yes, except all means what? If I had normal except clause, okay, in that case, how many, wherever the match was found, everywhere it will be deleted. But except all just deletes the occurrence once, right? So if I placed except in place of this, let's say for this particular student ID 21F11, okay, in the cross join, how many times will the student ID be present? 4
4
times.
times.
So if I place just except, then it will delete all those 4 times. Okay, but since I placed except all, it will delete it just once. So
But
for
except all should be deleting all, no, ma'am?
no, except all doesn't delete duplicates. Except deletes the duplicates. The name is confusing. Except all means it will delete once. Okay, but if you use just except, it will delete wherever it finds the occurrence.
Ma'am, it will delete the tuple from the cross product. 1.
Yeah, so how many tuples will be deleted from this first except all?
1.
Why?
4.
No.
5.
5.
5
5.
tuples will be deleted. For every student ID, I will delete 1 tuple from the cross product, right? Then again, there is one more except all, which is doing the same thing. So select
5.
ID from student. So again, the 5 times these tuples will be deleted. So total, how many tuples did I delete?
10.
10.
And
10.
how many were there in the cross product?
20.
20.
20.
So how many will be returned?
10.
10.
10.
So 10 is okay. This question has also been repeated.
Ma'am, here in the cross join there will be how many columns, ma'am?
Cross join, you are selecting only one column, no? So only ID
No,
column
no.
will be shown.
No, if I have to find the
Okay.
number of
Okay. If
columns.
you do select start from student cross course, then it
Yes.
will give ID, name, department name, uh, sorry, student dot department name, then again course ID, title, course dot department name. So 6
Okay.
columns will be there. Okay. This question is clear, everyone? Answer is 10.
Yes, ma'am.
Now this one. This is also interesting. See, first look at all the information. Okay, all the schema first. So we have students table, teachers table, courses, enrollment, all of this. The question is asking, choose the SQL query that will give output first name and email of all teachers whose phone numbers end with 8 and who do not teach history. So we need first name and email. So first of all the select statements should have first name and email, right? So teachers, that means it should come from which table? Teachers table.
Yes, ma'am.
Yes,
So
ma'am.
see, all the select statements are correct. Teachers dot first name, teachers dot email. This is present in all select statements. So we cannot eliminate anything from this. Next condition is whose phone number ends with 8. Ends with 8 means it should be what? Percentage 8.
First one is right.
So percentage 8 is present in which of the queries? This one
First
and this one.
two.
First, second,
First two.
These two I can
and
eliminate.
fourth.
Now next one is who do not teach history. So which one is correct?
First one.
First one.
First
This
one.
one is correct. Where course is not equal to history. So option A. Here we are not doing string matching, right? So we are not going to use like operator.
Huh? We can't use not like.
No, here we are not going to use not like. It is not a string matching. We are trying to find who doesn't teach history. So you
Okay.
check the
Yes.
course and attribute and you check where that it is not equal to history in any of the tuples.
Excuse me, ma'am. But in this case, if history is there, like in the same format,
Hmm.
so wouldn't it be like excluded, or it will be like it will affect the result?
No. We are checking now that they don't teach history. If they
That's
teach history, then
It's
this
not.
condition will be false.
no, first one is clear one. I'm talking about the second one, like course name not like history.
Yeah, this is not even valid. Okay, this like operator will only be
Should
used for
start with
string matching.
proportion. Ma'am, you should start with this proportion sign. Like and not like.
Proportion sign means?
this I don't know if I'm calling that right, but this 8, we have this before 8 with this symbol.
Oh, this is
Um,
percentage.
yes, ma'am. Yeah. So like and not like,
No,
we
no, like
usually.
and not like. See, it is not necessary that you must have the percentage. Okay, some cases you might not have percentage. If I say that find the names of teachers whose name have exactly 5 characters, so that will just be what, 5 dashes. So name like 5 dash. Okay, so this is
Ma'am,
used for string match.
there is also the different join method are used in the option A and B.
Yes,
So,
join is also different.
so
Like
is
here
there
you wrote just join. So where is the condition, right? Just join means what kind of join is this? Inner join.
okay, okay, inner join.
Okay, so you also have to give the condition that on what attribute. So that is also wrong here.
So,
But
like
if
this
there
thing,
is only one attribute in common, it will perform a natural join by default, I
Natural
guess.
join, so you have to specify that you want to perform natural join. So the query must contain natural join
But
keyword.
if we are using inner join, and if we haven't specified which attribute we are joining, or there will be only one common attribute between both the tables. Uh,
Will it do default natural join? I am not sure. I don't
I mean,
think
it
so.
does, but with inner joiner, we have not mentioned any inner keyword.
No, you can use just join also. That also works. Both inner join and join both will work.
so for
But
the inner join, we have to specify which attribute
yeah,
we are
which
using.
attribute you want, that you have to specify. That's mandatory in case of
In
inner
this
join.
case, it is not specified, so it will
Yeah.
be.
So that is also one violation. It is wrong from that also.
So, syntactically, it's wrong, right?
Yeah, it
Option
is
B is
wrong
incorrect.
syntactically.
But
Because join you have used but no condition is given.
got it. But this the we can use this condition in the predicate, na? Course name not like history. If in the
Let's
first
try this
option we
once
would have
in the
used if in the first option we
Postgres.
would have used after the end course name not like history, would it? I mean, would it not fetch
If
us
I
the
do
right result?
not like history, then what is happening? That means it is checking all the values and seeing whether it is history or not. Right. So if it is if some course name is not like history,
We're
so
excluding history.
and will be giving true when both conditions are true. So if let's say some person does teach history, so in that case this will give false. One and will become false. Yeah, this should work. Let's run this query once in the Postgres. Okay. Not like should work. If I replace this course name not like history in the first option, I think it should work.
Ma'am, is there anything called not like, or is it only like?
No, no, like is there, not like is also there.
Then it should work,
We
I
have
guess.
used like no for percentage rate.
We have used that, but not like also exists. It's not made up, it exists. Not like operator is also there. We don't use it much. Instead, whenever we want to check that something is not equal to a particular string or some value, then we use this operator. This one. This is not equal to in SQL terms. Okay, open and close these tree here. I think it should give the same result. Because
Ma'am,
technically it is correct.
can we use not like and then percentage sign?
Yeah, any string matching when you're doing, you can do that. It is not like this particular string. Yeah. Okay. So this thing I will check once that if I change it with this, if it will still work or not. Okay. I'll post this question in Discourse and mention the result that I got.
What does that less than and greater than?
This means not equal to. This means not equal. Okay. This I think everyone will get. So two tables are there, employee and manager. So how many tuples will be there as a result of the following query? So this is also one of your subquery questions, right? So first tell me what is the subquery getting? Select manager.age from manager where manager name is Rana. So what will
0.
this return? There is no such manager, right?
Null, ma'am.
So if it returns nothing, and what is the outer query? Select employee ID from employee where employee age is greater than all
All
of
the
what the
tuples.
inner
I.
subquery returns. So inner subquery is not returning anything. That means whatever employee I choose, their age will be greater than, it will always satisfy.
We are comparing with the null value, I guess. So,
In this case, nothing will be returned. Yeah, it is a null value.
so
But
if we
one thing is
compare null
there.
value, so it will also give the null one, right?
First of all, what I think is that null value comparisons are not allowed. You cannot compare null value with anything.
But we're using all, ma'am. All, like all
That
of
that's
subquery
the
that
keyword, that all of what value it is returning.
it's at
So it
having
is
heavy
not
sum.
returning anything. So if it doesn't return anything, that means every employee age that I get is greater. Since there is no such manager, that means no age will be selected. So that's why the answer is given as 5. But one thing to be thinking about, what I'm thinking about this is that if it returns null, then there should not be any comparison.
What if all null returns zero? Like all of nothing is
Yeah, all
zero.
of null is
All of
returning
nothing is
0
zero.
or not. Yeah,
Total
that
is
is
zero.
what we have to check. If it returns 0,
What
that
is
is
all?
all operator means what? See, if this one, say instead of Reina, if this was, take any manager name, whoever, that is, let's say Hazel is present. So if I took this, then what will the inner query return? The age of this particular manager, that is 19, right? So in this case, always this will return only one age, because here the names are not duplicates or anything. So every person has one particular age, it will return that. So it is saying that whatever is the age that is being returned, we will take those employee names in our answers whose age is greater than this value. Okay, so if there were even, actually all keyword is used in questions where there are more than one values that are being returned by the inner subquery. Okay, let's say if I took two managers whose ages I'm taking, so if that is 18 and 19, okay, then if I use all operator, then I will take those employees whose age is greater than both 18 and 19. So that's the work of all operator. But in this particular case, since nothing is going to be returned, so null will be returned here. But null is usually not compared with anything. Mm.
This
Null
is
doesn't
what
it
I
mean
got.
zero tuple?
No, null doesn't mean zero. Okay, null means nothing. So null doesn't qualify in any arithmetic operations.
No, ma'am, I
We cannot.
understood, but it will not return any tuple,
It
and
will not return
therefore there
anything.
will be zero tuple.
But you have to compare the age with something. Na, some value should be there.
Ma'am, all perform like count operator. Is it similar to count?
No, no. Count is different. Count is an aggregation function. Count counts the number of, like here, if you want number of employees, so count employee ID will give you that.
No.
5 employees. Okay.
If a column has all null values, then count returns zero, right?
Yeah, in this case, the null values do not qualify as values.
Mm-hmm.
But here, I don't think this is correct. I mean, you, how can you compare with null? This is also one question I will have to look into. Number 7. Okay, let's take this. This is simple relational algebra. So there are 3 tables: passenger, pilot, bookings. Choose the suitable query that will find the name of all passengers who flew from New York with pilot with this name and in flight number this. So which is the correct query? So these are all what type of queries?
Relational algebra.
Right. So it is easy to evaluate. So we have 3 different um, conditions. One is that the boarding is what? New York. That is flying from New York. So bookings, you can see boarding and destination are there, right? So the place where you're flying from is New York, place you're flying to is the destination, that is not given. So boarding has to be New York, pilot name has to be this James Van, and flight name, flight number should be 3005. So which option has all of this correct? But also look at the joins and everything. So if I look at option 1, okay. So pilot natural join bookings will give me what? Is there anything in common between these two? Pilot and booking? Pilot ID
ID.
is in common. Okay. So flight number is also common. So if I do natural join between these two, and from there I'm imposing the condition that boarding is New York, flight number is 3005, and pilot name is this. Okay. Now what am I projecting? The PID. So PID is present in bookings, so it will be present in pilot natural join bookings also. So I am projecting that passenger ID. Now, when I project this passenger ID, after that I have to do a natural join with passenger table itself. Okay. So if I do a natural join of just PID with passenger table, it is possible because PID is also present in passenger table. And from there, I'm getting the names of the passengers. So is this query correct?
Yes.
Okay, let's see the other queries also. What is wrong in second query?
Ma'am, pilot name, the projection of pilot name in the inner query.
Projection is pilot name. So pilot name is not present in passenger, so I cannot perform a natural join. Third query, what is wrong?
The first natural
The
join is
natural
done
join is
between
passenger and
passenger and
booking.
bookings, and we won't get any pilot.
So passenger and booking, if I do, what is in common? Nothing except PID, right?
Yes.
But what are my conditions? I
Pilot
need the
name needs to
pilot
give.
name.
Yes.
So that will come from pilot table. So that is not there. So you cannot impose this condition. So this is also wrong. This option, what is wrong?
Again, ma'am, the natural join.
Natural join between
Pilot
pilot and
and
passenger.
passenger.
So
That
what
has
is
nothing in
missing?
common. Nothing is in common, isn't it?
So pilot and passenger have nothing in common. So not possible
Not possible.
to do a natural join.
Ma'am,
So
can you
all
explain
these.
the options? Second option.
Second option C, the natural join is between pilot and bookings, fine. And then I'm imposing all of this condition. But what am I projecting? Pilot name. With
Oh,
pilot name attribute, you cannot do a natural join in passenger table because pilot name is not there in passenger table. So nothing in common.
got it.
Okay. So option 1 is correct. All other 3 are wrong. This question is clear, right?
Yes.
Okay.
Ma'am, I actually checked the condition we were discussing in the previous question regarding the all null.
Yeah, what happens?
Ma'am, it runs, ma'am.
It will run. So it
Yes,
will
ma'am.
give 5.
Yes, ma'am. I mean, it
Okay,
runs.
so even if it does return, yeah, that's what I think. So maybe I ran it in Postgres at that time.
I also checked in Postgres, ma'am. It's running there. So all null.
So even if it returns null, it will treat it like a 0. That everything greater than
Yes.
this. Okay, then so
It.
it is correct. 5 only will be the
I mean,
answer.
the subquery returns nothing like
Subquery is
only the
returning nothing.
like
So
just the
everything is greater than
attribute,
nothing. Yeah.
just the attribute number, and there is nothing below it.
Okay, okay. But
But
all 5 rows are being returned, right?
yes, ma'am. Then if it's greater, then the comparison is possible, ma'am. So
Okay, okay.
then it
So
returns something.
since we are not directly comparing with the null, that's why it is being possible since we have this all clause.
Yes.
So nothing is being returned by the inner subquery, so everything will be greater than that. So all 5. Yeah, this makes sense. Okay. Yeah, let's do one ERD question. We haven't done any of the ERD questions. So this is minimum number of tables required to convert given ERD into relational model. So this you tell me. First say how many strong entities are there.
3, ma'am.
So they will require one table each, right? Are there any
Yes.
multi-valued attributes?
Yes, ma'am. 2.
So those will require also different tables. So how many tables so far? 5.
5.
Now what are the types of relations? One to many, many to one. What type of relationship do you see?
Many to one and many to many.
Many to many. Both are many to many. This double
Yeah.
line is participation, right?
Yes, ma'am.
Yeah,
So
yeah.
since there
Total
are no
participation.
arrows, that means both are many to many relationships. In case of many to many relationships, what happens? There should be a separate table to maintain that m is to n relation, right? If I have just this attribute, this entity students, this entity teachers, and I have a many-to-many relationship between them. Forget about the multi-valued attributes. Then what is the minimum number of table required?
Then ma'am 3.
3. So both of these are many-to-many. That means for students and teachers, there will be one extra relation, and for students and courses also one extra relation will be required. So in total, how many?
Ma'am, I
7.
didn't get it.
7. See, 3 tables, for one for course, one for student, one for teacher. One for this multi-valued attribute, one for this multi-valued attribute. And since both relations are many to many, that means one extra relation here, one extra relation here. So total 7 relations are required.
Okay, because it is many to
Ah.
many.
Yeah,
If it
many to
is
many will always take 3 relations at least.
if it is one
Ah.
too many or
Yeah,
one to
then you
one.
don't need an extra. Then you don't need an extra relation.
Ma'am, strong entities, multi-valued ones, and also many to many. Any other things that would require a separate table, ma'am?
No, no, nothing else.
Only these three.
Yeah, only these 3.
Okay.
Any multi-valued attribute you see, that has to be in a separate table.
Ma'am, what about total participation? Does that require any separate
No,
table?
that won't play any role here. Okay. Here you just have to see what is the nature of relation. Okay, so this from
Can you show the question, please?
yeah, just a second.
Ma'am,
Ma'am,
an
here
instruction and enrollment to a table, what will be there?
Oh, these are not tables; these are relationships, right? But they are many to many. So students and teachers are M is to N relationship. That is many to many. So whenever we have M is to N relation, we need a separate relation to have that mapping. Okay, that many to many mapping has to be done in a separate relation. So one separate relation will be required for instructor relationship. One separate relation will be required for enrolled relationship. So these 2 extra tables are there. And 3 strong entities will require 3 independent tables. The total 5 tables and 2 separate multi-valued attributes are there. So those will require other tables, extra tables. So in total
Ma'am,
7 tables.
multi-valued is the attribute, right?
Yeah,
Multi-valued
but they have to be placed in a separate table. This phone number has to be placed in a separate table.
why, ma'am?
Because multi-valued attributes, are they even allowed?
Okay,
MVD.
so more than one value it will take.
Yeah,
So
so
that's
you
why
will
we have
take
to.
it in a
Okay.
separate table where for every student ID you will show how many phone numbers are there.
Yeah,
Okay, so this is 7.
Ma'am, can you please explain how do we interpret this total participation?
Total participation means what? Student has 2 lines, right? This means total participation. That means every student must be participating in this instructor relationship. That means every student must have some instructor. But on teacher's side, there is partial participation. That means every teacher might not be teaching some student. Right? There might be a teacher who is not teaching anyone. Maybe I
Okay,
hired
ma'am,
someone new
understood,
who is
ma'am.
not
Thank
teaching
you.
anyone. But
And in
in this
this
case,
case,
there
both.
are both. Yeah. So every student must have taken some course, and every course must have at least one student enrolled in it. Okay, that is total
Ma'am,
participation.
as a relation in
Hmm.
instructor and enrolled, what will be there? Like if we are making a table out of it.
So you will take that whatever is the primary key in students, whatever is the primary key in teachers. You can take the primary keys and see the mapping there. That okay, this student maps to this teacher. Now one student might map to many teachers, or one teacher might map to many students. So that this mapping will be showed in the separate relationship table.
Ma'am, while we are taking some maybe movie and someone who is watching, like that, uh, will there be a ticket in relation table? Like there was one question in the mock test where it is
Okay.
coming in the relation, like in the middle. The
Okay,
ticket
what is the relationship type? Like, is it many to many?
uh, 1 second, ma'am. Let me check.
Because usually many to many relations always take at least 3 tables. Some cases it might even be 4 tables. Okay, if the instructor relation itself has an attribute. That depends on what the ERD is. Okay, you find that, you show it to me. Let's just try to complete the question.
Ma'am, in which case it takes 4 tables, ma'am?
If the relationship itself has some attribute, in that case it might take 4 tables. That is
Can't it be
one
just
case.
contained within that table, relationship
No,
table?
mapping is not contained in that. I'll post a document. Okay, I have that document. I'll post it regarding this minimization of tables. Okay, there all the
Yes, ma'am,
conditions
it
are
is
given.
Thank you,
many to
ma'am.
many.
Yeah, I'll post
Ma'am,
it.
it is many to many.
Yeah, many to many means you will need to have at least 3 tables for the strong entities and for the mapping. Okay.
Like it is having person, watches, and movie. So watches is the relation. So there was some question like what will be the ticket number if we want to add a ticket number, then where it will be
Yeah,
shown.
that is a logical decision that you have to find out. So,
That
where
will
in
be
which
under watches because that's where we have this movie ID, which will be our
exactly.
ticket ID.
So that is where you see the mapping, right? So you can, it is logical to add it inside the map table where you have attributes from both the tables, right?
Okay, because I thought that we will only take the primary keys from both the table in that
Yeah, even if
relation.
you take, then you can add the ticket ID there also. It's fine. See, I think a detailed mock solution will be released. Has it been released? When is the mock submission last date?
Ma'am, it said us ungraded, so I can see the
Yeah,
solution
but we
even
will
now.
still. Okay, okay. Then the solution is also given. Okay, just check the solution once where it is being added. I think it should be added in the relationship table. Okay.
Ma'am, there is only the correct option given. It's not some explanation is not given.
Okay, which is the option?
Ma'am, it is the relation like watches.
Hmm. That is only making sense now, because in the watches relationship we will store that who is watching what movie. So corresponding ticket ID you can add. Adding it in separate tables, it doesn't make sense. Logical decision is to add it in the relation where the mapping is being shown. Okay,
Okay.
what is the time? One second. I don't have much time left. Let's just practice what are the important questions, okay, left, because still a lot of questions are left. Okay, let's do this one quickly. So first, consider SQL query to create these two tables, insurance and nominee. Okay, this question is important for this quiz one. See, create table insurance. Insurance ID is the primary key. Policy holder name is not null. Age also not null. Premium also not null. So 4 attributes. All of them are not null. Then nominee table. Nominee ID is primary key. Nominee name, relationship. Insurance ID, which is the foreign key, and it references the insurance ID in this insurance table. And on delete cascade is being applied. That means what? If I delete anything from insurance ID in insurance table, that will be reflected in the nominee table also. Corresponding insurance ID tuple has to be removed, right? So the question is asking delete from insurance where insurance ID INS 001. That is this one. Okay. So this means what? This entire tuple is deleted. So what will be the value of X if X represents the total number of rows in insurance and nominee table counted together? Okay.
5.
So this one will be removed also. Will it be removed or not? If I remove INS 001, this will be removed. So how
Yes,
many
ma'am.
rows
Yes,
are
ma'am.
left in insurance table? These three.
3.
And 2 rows from here. So total
Okay.
5 rows. Okay. Answer to this is 5. Now
The
this is an even,
entire tuple will be removed, right?
yeah, entire table. When you said delete from insurance where insurance ID is 10 INS 001. So wherever this value is present, that entire tuple will be deleted.
Okay, ma'am.
Now this is even more important. See, now if I insert all of these values into my tables. So insert into insurance values INS 005, Rakesh 24, 7,000. First see, is this a violation? Is INS 005 present anywhere? No. So the primary key violation is not there. I can enter. No null values also, fine. Insert into nominee values NM 004, whatever is present. So in nominee table, I'm inserting these three. Okay. And
So
next
only
it is
first one
saying
will be.
this one will be added NM004.
Yes, ma'am.
Okay. But in nominee table, what is my primary key? Nominee ID. So all of these are having same nominee ID. That means only the first one will be inserted. The next two are violating. Primary key cannot be repeated, right? So
Yes,
these
ma'am.
two rows will not be inserted. Then again insert into nominee ID, insurance ID. So only two values are being inserted. One is the primary key and one is the insurance ID. Rest of the values will be what? Null. So this nominee ID is valid. Now it is asking what is the output of the following query if I select everything from nominee table. So original nominee table had these three rows, right? Then what did I insert then? This row,
4 and
NM004,
10.
this. And there should be one more insertion, this one.
4 and 5.
So total how many tuples should be in my result? 5. So which of these?
This one, last one, ma'am.
This one. And also see NM0010, since I did not provide value for nominee name and relationship, it took null values. Okay, this type of question can also come. Okay, let's do one more, just this one, let's do. Okay, so this is the relational schema. I have three tables: drivers, brands, and designations. Okay, so drivers table, this designation ID comes from designations table. This is a foreign key. And drivers table, this brand ID comes from brands table as a foreign key. So what is the result of the following query? So this, I can see an intersect operation is there. That means there must be two sets. So this is the first set. Whatever is before the intersect and whatever is after the intersect is the second set, right? Okay. So first set is doing what? Select driver name from drivers, natural join designations. So if can I do natural join between these two, drivers and designation? Is there anything in
Yes.
common?
Designation ID.
Designation ID is in common. So I can perform a natural join.
Yes, ma'am.
Then condition is what? Where T dot salary is greater than all. Now what is the inner subquery? So we have to first evaluate the inner subquery. So select salary from designations, comma brands, comma drivers. What does this mean? Cross product of all three tables, right? Where the T dot designation ID is equal to D dot designation ID and brand ID is equal to brand ID in this table. And the brand name is Mercedes. So this is a little complex thing. First, let's see what is the inner subquery doing just from here to here. So I am selecting all the salaries, right? From what? From the cross product of these three tables where I have placed a condition that the designation ID should match between tables designations and drivers, and the brand ID should match between tables brand and drivers. So wherever these match, and there is an and condition that is joining the two, that is both conditions should prevail, and the brand name is Mercedes. So what does this mean? Salary of all Mercedes drivers? Yes or no?
Yes, ma'am.
Since, see, why I need to do all of this? Because to get the salary, I need the designation table. But the brand name Mercedes is present in the brand table, right? So I need to join these two tables somehow. So I have to take into account the drivers table because these brands and designation table don't have anything in common. That's why I needed to involve all three tables so that I can place this condition. So brand name is Mercedes and I need the salary for all the drivers of Mercedes. Now outer query is taking what? Select driver name from driver's natural join designations where T dot salary is greater than all of this. That means I need to find those driver names, right, whose salary is greater than salaries of all Mercedes drivers.
Right.
This is the first set. Second set is what? See, it is absolutely similar except the brand name is Ferrari. So this one means what? I will take the driver name of, but one more thing is different. It is less than. So this one is selecting the driver names from driver's table natural join designations where the salary of the driver is less than salary of all Ferrari drivers.
Yes, ma'am.
So what is the intersection between these two sets, right? That is what this query will return. So which option is correct?
Mercedes greater than Mercedes but less than Ferrari. I think first one.
Right. So names of all drivers whose salary is greater than Mercedes, all Mercedes drivers, but less than all Ferrari drivers. So this is the correct option. Is anyone there who did not understand this query? Okay. Should we do any more questions or? Yeah, let's do this one because
Ma'am,
we
is it
didn't do
possible
one.
to share this PDF on
Yeah,
chat window?
I'll share this PDF. I'll share it on Discourse. Okay.
Chat window,
I'll
ma'am, now.
chat window. Can I upload files there?
Ma'am, please share this
No,
PDF on the.
I have to upload it in some drive and then share the link. Na? Okay, let me just give
Ma'am,
me a second.
supplementary contents quiz one.
Okay. I'll ask Piyush sir if we can add it in supplementary contents. If not, I can just upload it in Discourse as the drive link. Okay, I'll give you the drive link. Okay, let's solve this last question one because we didn't do any on division operator. So food items divided by item info. So what are the uh, common attributes? Brand and rating. That means we have to take both of these together. So in our result should come from which attribute?
Item name.
Item name. So which item names will be there? Who have these corresponding combinations? Amul 5 and Nestle 4. These two combinations. So find that for chocolate I have Amul and 5 rating. For chocolate I also have Nestle and 4
Cake, ma'am,
rating. So
cake
chocolate
as
will be
well.
in my.
Chocolate and cake.
So
Chocolate
cake
and
has
cake.
Nestle 4.
Chocolate and cake.
Cake has Amul 5, right? Anything else has?
No, ma'am.
So which option? Option D. Right.
Ma'am, candy Amul 5.
Candy has Nestle 3.
3.
Right. It has to be 4.
No,
There
ma'am,
is
candy
4 here.
Amul and 5.
Amul 5 is okay, but it needs all the combinations, right? It should have for candy should have for Amul 5 as well as for Nestle 4. But it is Nestle 3. So this is wrong. It should correspond with these two combinations. Okay, so this is the last option is correct. Now 2 or 3 more questions are left. If you want, I can continue. I have no problem. Should we do it
Please
or
continue, ma'am.
do you? Okay, let's finish this. Okay, this is a theoretical question from week 1. So consider relational schema instructor, ID name, department name, salary. To change the data type of ID, which of the following categories of SQL commands is used?
DDL, ma'am.
DDL, ma'am.
DDL, data definition language. Because type of ID, it is a what level decision?
Schema.
So I have
Schema.
to change it in schema. Does anyone know what command I can use to do this?
Alter, ma'am.
Alter.
Alter
Alter.
table.
Alter.
And then add or remove.
So alter table is the DDL command. Yes. Okay, now this one. So 2 tables are given. It is asking which of the following queries will find out the names of all instructors whose department is finance or whose department is in Watson or Taylor building. Okay. So should we see the queries or do you want to see the tables?
Query,
Let's see the
ma'am.
queries.
Queries, ma'am.
Okay, 4 queries are there. So first query is saying select name from instructor I department D where a department name is the matching criteria and I dot department name is finance or building in Watson Taylor. Is this correct? See, These are the two
Yeah, this
tables, right?
can work.
Instructor and department. So I am matching based on what department name. So that is also fine. Now my criteria is that I need those instructors whose department is either finance or whose department is in Watson or Taylor building, right? So this one is selecting name from instructor cross join department, and then I'm imposing the condition department name should be same, and I dot department name is finance or building in Watson Taylor. So this should work. It's an
Yes,
MSQ.
ma'am.
Second one, it is saying select name from instructor I department D, where department is finance or building in Watson Taylor. Will
No,
this
ma'am.
work?
No, ma'am.
Why not?
And because the join is not there, na?
Because this equalizing condition is not there.
Yes, ma'am. Otherwise, we'll select all the finance department people and
Yeah.
all the people
So
within
there will
what?
also be such combinations where department is finance and building is Watson Taylor.
Yes, ma'am.
Right. Those will also be chosen. This is wrong. Third one is saying select name from instructor I department D, equalizing condition, and department name finance and building in Watson Taylor.
No, ma'am. And condition.
So this is also wrong. Last one is saying select name from instructor I natural join department D. This is natural join. That is, it will definitely be based on the department name. Where department name finance or
This
building
is
in
correct.
Watson Taylor.
This is correct.
So options A and D. Okay. Okay.
Ma'am, what is wrong with the option C? Can you explain again?
Option C and operator is there, no?
Sorry,
We have
option
to
B,
take all.
option B.
Option B, here we are not writing that clause that D dot department name should be equal to I dot department name. So we are doing just a cross join. That means what? Even instructors from finance department. See, finance department is in what building? Painter building. But here, if I do a cross join, then instructors who teach finance will also be matched with corresponding Watson and Taylor building rows, because cross product means every combination, right? So this professor, let's say Singh from finance, there will be such a tuple where it will be Singh finance and then Watson, biology Watson 9000, because every combination. So this will also be picked up. Okay. But we don't want that. We want either finance or the building is in Watson or Taylor. We don't want both.
Got it.
So this is wrong. Two more
Ma'am,
questions.
first and fourth, both are same join, na?
No, first one is cross join, then we put the equalizing condition, and this is a natural join. But they will both give the same result.
If it is
Okay.
equal to, then it is cross join, and then if
Cross join is when there is a comma. Okay, instructor I, comma, department D.
we are
Then in the where condition, if you want inner join, then you have to write instructor inner join department D.
okay, so here we are at the last getting natural join only.
Yeah, this will give same result as natural join. Because there is only one common attribute, department name.
If there are more common attributes,
Then it will be different than natural join. Then you are selecting that I am only equalizing these two common attributes, not all of them. But natural join by default takes all the common attributes.
okay, so here, as per the condition, we are getting the natural join only.
Yeah, in this particular case, both of these will have same effect, natural join or this.
Okay, ma'am.
Okay, now see this. So this is a table called cars. It has all these attributes: car ID, car name, car color, year of purchase, which is of integer type. Primary key is car ID, and check. There is a check condition that year of purchase for any of the tuples should be within these four values only. No other value is allowed. Okay. So initially I have these two records in my cards table. Now which among the following will cause an integrity constraint violation? So this is an MSQ. Might be more than one answer. So first option C, insert into cars. C3, fine, primary key is not violated. McLaren, this is fine. Orange,
B and D
and
must be the
year of
answer.
purchase.
Second and fourth, ma'am.
B and D.
So this is correct.
Yes, this is
Option
correct.
B, C2. So this is primary key violation since C2 is already present. So this is causing the violation. This is one of the answers. Option C, C4 Williams Black 2002, everything is
This
okay.
is okay.
Valid, ma'am.
So insert into, this is C5 is fine, primary key not violated, but 2005 is
Color,
not in
I
this.
mean, year of purchase.
Violation.
Yes, year of purchase is not in the range of values. So B and D, right? I'm sorry, this is correct. This is wrong.
Ma'am, why first one is wrong?
First one is wrong. What do we need to find? Which will cause an integrity constraint violation? First one is not causing any violation. Primary key is also fine. 2003 is also in the range of values provided. Right. So this is not causing any integrity violation. Options B and D are causing violations. So those are our options.
Which will cause integrity violation. Okay.
Yeah.
Okay.
Okay. Last question. See. So which of the following statements are correct? First option is saying there might exist a company that has not produced any items. So company and items. So company has total participation. That means what? Every company produces at least one item. So can there be a company that does not produce any items?
No, ma'am.
No,
So
ma'am.
first option is wrong. Second option, there might exist an item that has not been ordered by any customer. So items has what?
Yes.
Partial participation. So there might be some items which are not ordered by anyone. So this is correct. Third option is a company can produce at most one item. So this is the many side. That means company can produce more than one items, but every item must be produced by a particular company. That's why the arrowhead is here. So this third
Ma'am, can
option
you
is also,
repeat? Why
third
arrowhead?
option is saying that company can produce at most one item. But here this is a many to one relation, like one side is this. Wherever the arrowhead is pointing is the one side. That means every item must be produced by at most one company or exactly one company. But a company can produce a number of items. Because this is the many side.
Okay. 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 Okay.
Okay.
Yeah.
And last option is saying customer can buy more than one item. So these are both many sides. So a customer can buy as many items as they want, or an item can be bought by more than one customer. So both are correct. Okay. Is this question clear? Okay. So
Yes,
that's
ma'am.
all of them. Okay, we discussed all of them. Lot of questions. So I will upload this PDF in Discourse. Okay.
Ma'am, where did you get these questions from?
These are all PYQs. Okay. I just compiled the ones which are important.
Okay.
Yeah, I will give you all the right answers, solutions, everything. Okay. I'll add the solutions that are not given in the PDF, then I'll upload it. Okay, everyone. I hope
Ma'am, just one
yeah.
clarification again. I've just got my head jumbled about this accept and accept all. So accept basically gives you all the
Except
this thing you said.
except will delete all the duplicates. Okay. If I say except some value 1, so take out the value 1 from some set. So if that set has, let's say, 2 or 3 1 values present, it except will take out all of them. But if I
All
write
of them.
except
Okay.
all, it will just take out the first occurrence.
The first occurrence. Okay,
Yeah.
I'll remember it like that. Okay, thank you.
Okay. So I hope this session was a bit helpful for you. You can let me know if
Yes,
there
ma'am.
are any more doubts. Okay.
Yes, ma'am.
Yes.
It was very helpful.
Yes, ma'am. It was really helpful. Thank you, ma'am.
Thank you. So please join tomorrow's session also, because I think the mock will be discussed. Okay. All right. Good night, everyone. Thank you.
Good night, ma'am.
Good
Thank you,
night,
ma'am.
ma'am.
Thank you, ma'am.
Thank you, ma'am. Uh, ma'am, I'm not sure if
Yes.
you're still here, but I remember you sharing a document, ma'am, with for a
Yeah,
concept
yeah.
clearance.
I'll share it on Discord. Okay, I'll give the drive link.
Okay, ma'am. Thank you, ma'am. This one and question link and the document or topic.
Can you just remind me once to share it for that ERD topic? Okay, I might forget that. Just message me once on Discord, so I will share it. Okay.
Okay, ma'am. Thank you, ma'am.
Okay.